Yes, sir. Sir Pubali here. Good morning, sir.
No, Firoza is calling me. Hello. अच्छा अच्छा Hello, Puvali.
Yes, sir.
Professor Sahula has joined.
No, sir, not yet.
Okay. Hello, Puvali.
Yes, sir. Yes, sir. Hello. Hello.
Bali, I think so. There is a network issue. Sir may receive some phone call. Yeah, I think so. Yeah. Uh, Sir, may I request? Yeah.
Am I audible now?
Yes, sir.
Yes, sir.
Yeah. So Professor Sahula is joining and
Sir,
go
Gaurav sir is also.
joining bus. So once we have Professor Gaurav, Professor Sahula joined, myself, Bharat already here, we can start.
Uh, Thank you, sir.
Okay. Are you controlling this microphone also? Because at times it gets muted and then it comes again.
No, sir.
Okay, okay.
Thank you, sir.
Thank you.
Morning, sir.
Good morning, Professor Saula. Morning.
Good morning. Good morning. Best wishes.
Uh,
Participation अच्छा है सर
So,
आपका. I saw that.
ठीक है. Everything
हाँ
went well, although because of this
हाँ नहीं
COVID,
अच्छा है.
we
हाँ
faced
नहीं
a lot of
हाँ नहीं
difficulties
आप
in organ.
आप yeah, but yours and your team efforts also speak for it. It's a good number.
Good morning, Salo sir.
Yeah, good morning, Bharat. Good morning.
Sir, how are you?
Fine, sir. As usual.
So, Pubali, can we start? Professor Saula is already joined.
Yes, sir.
Uh, Dr. Gaurav has already joined.
No, sir. Sir Gaurav sir has not yet joined.
So, let us start. And by this time, he will also join.
Oh, okay, sir.
Okay, sir.
Firoza ma'am?
Yeah, sure. Yeah.
Yeah.
Thank you, Bubali. Thank you, sir. Good
Yes.
morning to all the respected dignitaries and participants. I, Firoza Haq, on behalf of Electronics and ICT Academy at IIT Guwahati, NIT Patna, and MNIT Jaipur, would like to welcome you all for the inaugural session for the 2-week online joint faculty development program on wireless communication technologies for IoT. We are happy to announce that at IIT Guwahati, we received total 305 registration, out of which we are having 252 faculty registration. At NIT Patna, we received 360 registration, out of which we are having 218 faculty registration. We are very fortunate to have with us the coordinator for this program, Professor Ratnajit Bhattacharjee sir. Professor Ratnajit Bhattacharjee sir is also the principal investigator of the Electronics and ICT Academy at IIT Guwahati and professor of Department of EEE at IIT Guwahati. I request Professor Ratnajit Bhattacharjee sir to please start with the inaugural session, sir.
Good morning. Uh, Good morning, Professor Saula, Dr. Bharat,
Good morning, sir.
and my fellow colleagues from E&ICT Academy. So, we are planning a series of courses, and because of this lockdown scenario, we had to change our modalities the way we used to earlier offer the online FDP courses. So, this is a new experience for all of us. And the topic which we are covering in this FDP is very, very relevant. As you know, everybody speaks of IoT nowadays. So this particular course, which is the wireless communication technologies for Internet of Things, so this will try to cover various aspects of IoT, and we are also assisted by our industry partner, and we have actually put lot of effort to design this course. The experts from the Uniconverge Technologies, who are our industry partner, so they will deliver lectures. They have designed actually hands-on session. So this course is not only going to be only on theory, but also doing some hands-on, particularly using internet. So it is not a physical laboratory, definitely, but you will see how you can do things over internet, and that will be, I think, a very good experience for all the participants. I have a session, introductory session on IoT immediately after this inaugural, so I am not going much into the details of the IoT and how we have designed these courses. I will talk about this in that session. But today we are fortunate to have with us Professor Sahula, who is coordinating all the uh, FDPs that we are doing during this lockdown situation. And he has taken a lot of efforts and pains in getting these FDPs in place. So I would rather want that the participant hear from him some of his experiences, how he organized these FDPs online mode during this lockdown period. So over to you, Pubali. Yeah, Firoza.
Thank you, sir. We are very fortunate to have with us the overall coordinator for this joint FDP. I would request Professor Sahula, sir, to please say a few words, few encouraging words to the participant. Sir, please.
Yeah, thank you, Firoza. Thanks, Professor Bhattacharya. I think it is effort of all members who are CIs and other members whose effort have actually borne fruit, and these programs have taken good shape. I am just getting name out of that being a conveyor to the ministry, so I got my name in that in between there. Thank you, Professor Bhattacharya. I congratulate IIT Guwahati, Professor Bhattacharya, Professor Gaurav Trivedi, and Firoza as a team. Like their FDP organization efforts are so well in place that it is well participated, and the kind of speakers, industry interaction, and inviting the speaker, that part is also very strong there. So I wish all the best to all the participants because this program is quite well woven. I think they will benefit from the interaction with the experts that way. So thank you, Professor Bhattacharya, and I congratulate you again for a good program in place. I'm happy to join this inaugural function. Yeah, thank you very much.
Thank you.
Thank you, sir, for the encouraging words. We are also very fortunate to have with us Dr. Bharat Gupta, sir. Dr. Bharat Gupta, sir, is the co-principal coordinator for this program, and he is also the principal investigator for the Electronics and ICT Academy at NIT Patna. I would request Dr. Bharat Gupta, sir, to please welcome the participant and say a few words to the participant. Sir, please.
Thank you, Firoza. I hope my voice is coming. Is it okay,
Yes, sir.
Firoza? Okay.
Yes, sir. It is okay, sir.
Okay. Thank you, Firoza, for just inviting me and the good introduction. Very good morning to all the chief investigator of the academies, academic level coordinators from IIT Guwahati, NIT Patna, and MNIT Jaipur, and the proctor coordinators around the nation, all experts from academia and industry, and all participants of this program. On behalf of E&ICT Academy, IIT Guwahati, and NIT Patna, I welcome you all to this exciting and the informative faculty development program on wireless communication technologies for IoT. The course is basically designed to provide the in-depth knowledge of the practical aspects of the IoT. As Professor Ratnijit has already mentioned that this is IoT is now a buzzword and everybody is working on this part. And so we are trying to give you the basic as well as the advanced knowledge that is required to make a IoT system. So we are trying to give you first initially giving you the basic knowledge of the sensor, actuator, controller, IoT architectures, communication protocol, security aspects that all are required to cover to make an IoT system. And along with that, we are giving you a glimpse of Industry 4, which adds the value to the program because we are moving towards the Industry 4. Because right now we are working in the Industry 3.0, we are moving toward the Industry 4.0. So how we look towards the Industry 4.0, so that will be that aspects are also are touched in this program, so that all the participants will be benefited and they can work towards that direction. The IIT Guwahati is already updated. It's my also duty to update the numbers. So as a co-principal coordinator, in industry in total, we have around 700 participants for attending this program, in which around 360 from NIT Patna. I really thanks to all the academic level coordinator and the proctor coordinators from NIT Patna. I wish you all a great learning during this program, and I assure that we will be here to help you out at our level best for any problem during this course. We hope this course will help you with your academic and the research pursuit. And I thank you, all of you, to joining this program. Thank you, sir, and thank you all once again. Firoza, I'm over.
Thank you, sir, for your welcoming words, sir. We are very fortunate to have with us the co-principal investigator of Electronics and ICT Academy at IIT Guwahati, Dr. Gaurav Trivedi, sir. I request Dr. Gaurav Trivedi, sir, to please give a welcome note to the participants, sir. Thank you, sir.
Yeah. Thank you, Firoza. Professor Ratni Bhattacharya, Professor Bharat Gupta, and Professor Sahula, they all have conveyed the right message about this particular program. So I will not take much time. I will just wish all the participants a very good luck. And in this COVID pandemic, since we are doing this program online, if there is any problem, if you run into any problem, something is not running, they can always get back to us any point of time. And I just say that stay safe and healthy wherever you are, and keep your society staying healthy as well. Thanks a lot once again. Wish everybody a very good luck.
Thank you, sir, for your. Yeah, thank you, sir. We are also having with us Mr. Kaushalendra, sir. He is the resource person who has designed this program, and he has already taken a webinar yesterday, which all the participants enjoyed a lot. And with your presentation, the participants are able to install all the software. So may I request Kaushalendra, sir, to say a few words, sir? Kaushalendra, sir, please. Hello, Kaushalendra, sir.
I think he's speaking, but he's not audible to us.
Yeah.
Yes, sir. Uh, okay, sir, we will look into the issue. We are just coordinating with Kaushalendra, sir. And moving to the next, we are the effort of the academic level coordinator is almost like a support system, because without their effort, it was not possible for us to get such a large participation. So with this, I would like to request Rakesh Ranjan sir and Richa Agarwal ma'am from NIT Patna to please say a few words. Rakesh sir and Richa ma'am are the academic level coordinator from NIT Patna, and they helped us a lot in organizing and coordinating with the participant and making this organization of the first webinar a success. So may I request Ranjan sir to please say a few words, sir?
Thank you. Thank you for giving me this opportunity. Am I audible? Hello?
Yeah, you
Yes,
are audible,
yes,
sir.
Yeah.
Yes, sir.
Yeah.
Please,
Yeah,
sir.
you're
Uh, um, thank you to all the principal coordinators of this program, this faculty development program, for organizing such a great program which cover various aspects of the wireless technology for the IoT applications, including from basics to various embedded kind of thing, and various design principle and industry 4 aspects of the IoT based on the wireless. I would like to say that this course will be very useful to all the participants, those who have joined this from both IIT Guwahati and NIT Patna. And I'm thankful to Dr. Bharat Gupta who has helped me a lot to organize or to make this faculty development program uh, in such a great manner. I'm also thankful to Professor Ratnaji Bhattacharya sir for organizing such a great faculty development. Thank you very much.
Thank you, sir. May I request Richa ma'am to say a few words? Richa ma'am?
Hello, Richa ma'am. Hello, Richa ma'am is there?
Yeah, Richa ma'am is connected, but I think so.
Maybe there is a problem in at her side, so we can continue.
Hello, Firoja.
Yes, sir. Yes, sir, please.
Firoza,
Thank you, sir.
Mr. Koshalendra, he could connect. You can
Yes, sir.
so
Sir,
you can invite.
Kaushalendra sir informed me that he is having some issue with his mic, so he asked me to continue as he has already
Okay.
addressed to the participant yesterday.
Okay.
Thank you, sir. Thank you all. And participation from across India. We are having 6 proctor coordinators at IIT Guwahati and 6 proctor coordinators at NIT Patna. Thank you for joining us and helping us in making this event a success. We will work together for the success of this event. With this, I would request Professor Ratnajit sir to please conclude the session, sir.
Hello.
Yes, sir.
So my congratulations actually goes to my team at E&ICT Academy, the team members of E&ICT Academy at Patna, and also our industry partner who has actually worked for last I should say a couple of months tirelessly to put a good program to the participants. Now we have worked hard, and it is we are fortunate to have a large number of participants joining this program. Now it is to see how we go with this program in the next 15 days. And I hope all of us, with the same amount of dedication and commitment, will try to make this course a really grand, successful course. And if the participants of this course at the end of the course, they feel that they have learned something from the course, that will be our achievement. So we do not want to prolong this session any further. I once again thank everybody who has contributed to the bringing this program, making this program possible, and I will expect that this every event will uh, be successful. I understand there will be some glitches here and there, like internet connectivity, sound, visibility, sound. All these issues will be there. We'll have to work with all these practical limitations and make this course successful. Thank you all.
Yeah, thank you, Professor Bhattacharya.
Thank you, sir.
Yeah, Bharat, congrats. I just forgot to mention your efforts. Congrats.
Thank you, sir.
Firoza, do you have any?
Yes.
Could he connect, Mr. Kushalendra?
No, sir, we will resolve the issue. We will make him connected, sir. Now we are having a 15 minutes break, sir, and we will start at 9:45.
Yeah, the technical sessions. So on
Yes.
behalf of E&ICT Academy, IIT Guwahati, I thank everyone all the dignitaries who has actually joined this inaugural program and encourage the participants. And I hope
Sir,
in future also we will keep on getting such support from our partners.
sir, just sorry for the interruption, sir. Actually, Sukumar Nandi sir just joined, sir.
Okay, so you ask him, you please request him to
Yeah.
say a few words and
We are very fortunate to have with us our resource person and a professor from Computer Science Department, Professor Sukumar Nandi, sir. I would request Sukumar Nandi, sir, to please address to the participant and sir, say a few words, sir.
Good morning to everyone.
Good morning, sir.
I joined late. I just almost at the end. I was busy, so sorry for late. I am here to listen also as well as deliver also. So we are in a teaching learning process, and we always learn more than teaching, and we learn from our student more or our co-worker more compared to our teaching, because we are senior persons, we don't get time to learn. So it is a very nice options to learn ourselves and deliver to our co-worker and those who are students and other people are with us, they want to learn, and all together, all of us together, we can learn a lot of things, and hope this FDP program will learn a lot about the this IoT and its usage in different scenarios. Hope all of us will enjoy this program. Thank you.
I could see Mr. Narang is also there. He has just joined.
Yes, sir. Thank you, Sukumar Nandi, sir, for your welcoming words. We are also fortunate to have with us Mr. Narang N. Kishore, mentor and principal design architect, Narmix Techno Labs Private Limited. I request Narang, sir, to please say a few words, sir.
Thank you all, and thank you, Professor Ranjan and Bharat, for inviting me to this very interesting faculty development program. I see there's a lot of relevant topics that you have selected. The way I see academia and industry are partners. We think we keep on learning from each other and collaborating with each other. And particularly in the field of IoT and today's latest wireless technologies or any other disruptive technologies, it's very crucial to collaborate with the industry and for academia, as well as for industry to collaborate with academia. And the way I look at it, I've been into design for last 4 decades. And the way I see design and training are two sides of the same coin. And I'm very happy to be part of this. I think I'll be sharing my perspective a little later after Professor Ranjan Bhattacharya, and hope to enjoy learning and attending all the sessions from senior faculty members. And I'll also share my perspective with that. I think I'll not like to take more time. Thank you very much for giving the opportunity.
Thank you, Narang,
Thank you, sir. So with this, we are towards the end for this inaugural session. There are a few important announcements for the participants. We request all the participants to please join with their registered email ID, because the registered email ID will be used for marking attendance. And we also request you that the chat option is disabled and we have enabled the question answer section. During the session, you all are requested to please drop your queries in the question answer section. We will address to the queries. So with this, we are towards the end of this inaugural session. Thank you all for joining us and enlightening us. We will be connecting again at 9:45 to start with the technical session. Thank you.
Yeah, thanks, Professor. Bye.
Thank you. Thank you very much.
Thank you, everyone. Thank you so much for joining this
Bye,
inaugural
Bharat.
session.
Yeah, sorry, sir, just for interruption, sir. Just now, Firdaus sir also joined. Ratnajit sir.
Yeah, but just ask him to tell hello and we'll continue.
Yeah. Good morning, Firdaus sir. Yeah.
I was
Sir,
proceeding to office and I got delayed, but it's my pleasure to be in the inaugural session. Thank you very much. Hope to meet the participant later in my session.
Thank you, sir.
Firoza,
Yes, sir.
I try my slides. Can you give me the permission?
Sir, we have already given you the privilege.
So share content.
Yes,
I
sir.
can go and.
Yes, sir. The slides are visible, sir.
Okay. If I want to share multiple documents, then how will I go? Suppose I want to switch from one document to the other.
So you can
There are
just.
links.
Patnaji,
Yeah.
can make available your desktop also. Is it possible?
Yes.
Yes, sir. Yes, sir.
Then you can
S-
add any document anytime.
Sir, I would request you to please click. So first of all, you can stop sharing the screen.
Yeah.
Yes, sir. Yeah. Then, sir, I would request you to please go to the third tab in the top of the screen as share. File, edit. Then we are having a tab as share.
Yeah.
In the top of the screen, yes, sir. So please
Yeah.
click over there.
Yeah.
So then, sir, you might be getting several options over there. Share content. So what are the?
If I do my
Yes,
screen,
sir.
then it.
Yes, sir. Yes, sir. This is your screen now. Like whatever documents you want to share. So if you open the document, it will be visible to us. Your whole desktop screen is now visible to us, sir. So whatever document you open, sir, it will get visible to all of us, sir.
Okay. So now, can you?
Yes, sir.
Yes, sir.
If I. You can.
Sir, it has not been like in full screen yet.
Yes, sir.
Yes,
Now
sir.
it is
Yes,
visible.
sir.
Yeah. So I can run it. If you click this link, do you? See? Yeah. You see it's changed.
Yes, sir.
Then it is all right.
So yes, sir.
So let it be like this. You tell me whenever you have all the participants in place. Huh?
Okay, sir.
sure, sir, sure. Yeah, thank you, sir.
Hello.
Yes, sir.
Should we start?
Yes, sir, we can start, sir. Like 306 participants joined, sir, and 310, I think, yeah.
To you, and we start the first session of this particular program, wireless communication technologies for IoT. And this first lecture or presentation slot will be shared by myself and Mr. Narang, who is from industry. So in this particular presentation, I will try to give a brief overview of what Internet of Things is, also try to discuss the things we have included in this particular program, this 15-day FDP, and then I'll pass this session to my fellow colleague from industry, Mr. Narang, who has wide experience in this area, and he will discuss about the market related issues of IIT and the business scope that exists. So, understand from what Firoza has told, a large number of faculty members are joining this course, and IoT is now being formally taught in many of the universities as a full-fledged subject in many places. And concept of Internet of Things has essentially, as far as I see, it has evolved from R&D. Initially, it was R&D, and then gradually it has Internet of Things. So we'll spend some time in understanding how different IoT, and we'll try to analyze this definition a little bit in depth so that we get a feeling of what we mean by IoT. Because it is a very common word now. You ask everybody, will at least has heard. So let us go a little deep into it. So it is said Kevin was director of the Auto ID Center. He coined this term for the first time in 1999 while working on a presentation for Procter & Gamble in the context of supply chains. And this is his claim. Of course, if I go RFID, he said in his work, I could be wrong. I am fairly sure the phrase Internet of Things started live as the title of a presentation I made at Procter & Gamble in 99. So this is how RFID, from RFID, Internet of Things, this terminology was coined. But of course, there are other claims as well. Let me see if I can share it with you. So, though Kevin Aston, then executive Auto IT Center, claims to have coined the term Internet of Things, according to Professor angels. The term was used in a 1997 publication by International Telecommunication Union. See that there are still debates how this term originated, but one thing, whoever has coined this term, it is not very old. It is either 99 or 97, only around 20 years of age, and this is very new, got its popularity very fast. So how do we Internet of Things? So let us see few definitions and try to understand meaning of this. In their glossary of terms, they have defined the of physical objects that contain embedded hence or their internal states or external environment. So now we are getting little bit technical. First of all, it is a network of objects. I will explain even more. Must contain some embedded technology, should be capable of communicating, and it should be capable of sensing, interact with their internal external environment. So some idea that it is Internet of Things to be a network. It is not a single device. It will do some sort of sensing, and then it will, this network transmitting information from one place to the other, and also should with the external environment. So let us move on to some other definitions. ITU, in their recommendation, ITU published in 2012, they defined the internet. Now the scope is here expanding. It is a global infrastructure information society. So you see new terminologies coming in. It is a global infrastructure for the information society. So we must know society, enabling advanced services by interconnecting physical and virtual things, existing and evolving interoperable information and communication technologies. So you can see that IoT, lot of things depends on the it is sensing. It is not IoT. It has sense, and but with the passage of time, people added more functionality into the while defining IoT. Understand, and we try to see the scope of this terminology, inter have grown, and how it many new issues. Okay. There was some issue with the sound quality because of the video being on. So I put it off.
Thank you, sir.
Me properly now?
Yes, sir.
Yeah. Yeah. So a very simple definition which says items each embedded with sensors. So now we are talking of the term items each embedded with sensors. So ultimately you have items which are embedded with sensors and which to the internet. This further, then what we get an IoT system. Now IoT system where typically a massive number of objects. I'll come to the what those objects, things, sense or device are connected through communication and infrastructure, value-added services, intelligent data processing for application. Now it has included more terminologies. Earlier we were talking of sensors, which has items which had embedded sensors, which can gather data, communicate over internet. Now we are in new terminologies, intelligent data processing and management, different application. So we can see that the and the scope of this particular term thing, it is expanding as we are moving into variety of applications. For example, smart health, smart grid, smart home, smart transportation. There are a lot of things which people are trying to come up. I will discuss later on. I have a slide on the possible areas of applications, and there we'll discuss some of these issues. I hope you have now got an idea that a IoT essentially requires sensor communication technologies, internet. You would like to have intelligent data processing, then storage will come into picture. Based on all these requirements and all this aspect and looking into the trends in the application of IoTs, we have actually this particular syllabus for this particular course or FDP. We have started with very basic and we have topics communication technologies. We have a complete session on the sensors and how these sensors will work. Today, the internet, and also everything is on the cloud. So we have on cloud and cloud-based applications involving IoTs. Activities, whatever you do using internet, cloud, sensing, and we gradually move towards smart things, smart automation. Finally, we need to have everything done in a very anybody cannot change the functionality or intrude into your network and do some malfunctioning. So security also becomes a important aspect of realizing practical IoT systems can be actually used to attacks and other things. So we have again another complete session on security aspects of IoT. In this course, our endeavor has to invite the experts both from academia who are working themselves those domains, and then we have very experienced who will be able to integrate these small technology domains, and they will actually have IoT functionalities realized, and we will have some hands-on sessions as well. Explaining in more detail what we mean by Internet of Things, we have so far got an idea what Internet of Things represents. So slightly more so it's an ecosystem of physical which are through internet. So in could for example with a with built-in sensor, or an has been assigned an IP address, the whenever you are in the internet, you must have many cases. Till now we are using IP version 4, but IP version 6 is also being used, and the address space provided by IP version 6 is huge. Take care of large number of the things. I will come billions. So this is very important. And have the ability to collect and transfer data over a network without manual or intervention. Now, what we do in the Internet of Things, all things that are being connected to the internet can be put into three categories. Things that so it is essentially if you are doing some monitoring somewhere, health of you want to health of a crop, you want to see in where some landslide is taking place. So when you are doing monitoring application, you are only collecting information and then you somewhere else for processing. But in IoT, and when things are to be performed automatically after analyzing the data or information gathered, then you will have to initiate some action. So that receive information and act on it. People are talking of today homes where switch on your refrigerator or switch on before you enter your home as you are approaching home. So you are actually turning on certain device, you are acting, so your this particular thing is receiving information and acting on your behalf. And there are also things which can do. So I think this gives a good amount of idea of the ecosystem of IoT over which it is built. Comes how IoT organized basic architecture of IoT. I will not go into the details. We have already seen that we must mechanism for sensing the sensors, and then another layer and data. And once we have these two, we build. Hello. Hello, Firoza.
Yes, sir.
Am I
Yes, sir.
audible? There was a power
Yes, sir.
cut.
Yes, sir.
Oh, I kept a backup with my mobile, so the connectivity is on. Okay, fine.
Okay. Thank you, sir.
So these are the three basic layers in the IoT architecture. And in some recent literature, they are also referred to as perception layer, the lowest layer, then middle layer in the three-layer architecture is the network layer, and finally the application layer. So this simple basic three-layer architecture of IoT has further been expanded. As I am telling, the definition of IoT itself is changing, and to include many other recently introduced features, now people go for 5-layer architecture for IoT. So we have business layer at the topmost, application layer, processing layer, layer, and the perception layer. And based as given, we can further expand slightly the activities performed in these layers. So perception layer, this is based on the reference I have shown, a paper by Liu et al. So you have a number of sensors, actuators, RFID tags, etc. And they interact with the physical object. So this is the perception layer. Then transport layer or transmission layer. Here, the information transmission take place. And with every year, the communication technologies are changing. So here, in some cases, we may use short range communication technologies like your Bluetooth, then medium range communication technologies, say Wi-Fi, and long range communication technologies. Now, there has been some communication technologies which have been developed specifically targeting IoT. We will discuss in that session of the communication technologies. People nowadays talk of very much about technologies like LoRa range. And so we have home area network, field area network, wide area network. So this is the transportation layer where data transmission takes place. Then comes the processing layer or the middle layer where we have the database, cloud computing, then ubiquitous computing, and there you make the decision. So this is the layer where a lot of processing take place. And finally, we have the application layer where we nowadays talk of smart applications, smart grid, smart healthcare, smart building, smart transport. Everybody is talking of something smart. And all this application layer essentially targets a higher layer, which is the business. So IoT business, IoT market, it is expanding like anything. And today, Cisco has done a survey. So this is from a different perspective. Around 2008-9, the number of connected device has actually crossed the world population. And if you take that of 2020, today's scenario, then what we get is the number of connected devices is 7 to 8 times more than the world population. So you can imagine that for every person, there are 6 to 7 connected devices. And the way the internet and other technologies are proliferating and getting into our everyday activities, the number of connected devices today, when I am delivering this, I am using a number of connected devices. So the number of connected devices are increasing, and this is actually providing a lot of business opportunities, and people are coming up with newer and newer applications. I will talk about some of the applications areas where people have used IoTs. So building and home automation that I have already mentioned, this is one major application area. Manufacturing, so IoT and automated manufacturing is another major area which is coming up. Agriculture, there is a lot of scope of using IoT based technologies in the agricultural scenario for monitoring the crop growth, then increasing productivity. Medical and healthcare system, this is one major area where a lot of applications are possible. In fact, only yesterday I was reading one paper on application of IoT for COVID-19, and it has been published during this lockdown period. So they have proposed how IoT can be used for effectively monitoring the people who are under quarantine and also the people who are undergoing treatment because of this COVID. So you can see that medical and healthcare is one major area where IoT application can take place. Please note that I am not lecture, I am not taking up any particular application area. I am just mentioning some of the possible areas where IoT can be applied. And during this course, when we cover different aspects of various systems, examples will be drawn from such application areas. Media, another area. Environmental and infrastructure monitoring. This is very, very important. IoT can be used effectively for monitoring the health of major infrastructures. Environment, education, energy management. So this is very, very important area, and smart grids and smart energy management systems people are talking of. There IoT will find a lot of application. Smart cities, wildlife monitoring and tracking. This is another area where IoT has a lot of promise. We can actually monitor the wildlife and track their activities. Transportation. So IoT is considered to provide solution. It is considered to provide solution to the traffic congestion that we are facing. So you can see that the application areas, and that's so on. These are some of the representative areas where the IoT applications people have tried. But apart from that, there are many other areas where IoT can be applied. Now, all these activities in IoT, it is possible to perform and expand the capabilities, but there are certain major challenges also. I will conclude this particular session after discussing some of the challenges faced by IoT, and one of the major challenges is the scalability. So today you put sensors, start network, everything, and tomorrow your requirement increases. So how you come up with a scalable architecture where even if you add new units and still your network also can grow, you can connect new sensors in the existing infrastructure and it scales up. Scalability is a major issue which has to be addressed while designing IoT type of net systems and networks. Easing security concerns. Now, this is, I already discussed, security is a major issue in IoT-based application, particularly when you are doing automation and you are operating gadgets, you are operating units remotely by using communication means, and if your signals are intercepted and modified, then it may be hazardous. So how to protect the IoT infrastructure from the external intervention is also a issue of major concern. Technological standardization, it is very, very important because different the technologies which are being used, the frequency bands that are being used. For example, when I discuss communication technologies for IoT, I'll mention that some of the frequency bands which are been made for use ISM band in India, these are not covering the frequency range of LoRa communication. So this type of issues come up because the technologies are being developed at one country, it is being used at another country, and lot of standardization is needed. And of course, this is where the industries, they collaborate, and I think my next speaker, Mr. Narang, will actually touch upon some of these issues. So technological standardization is another issue which we need to consider. Software complexity, you can see there are billions of connected devices and they are to communicate through internet. So there are lot of different types of sensors are there. So you require software at every level, right from the software for the devices to software for communication. So software complexity is another issue which needs to be addressed while designing IoT system. Connectivity issues. The bandwidth is limited. Mostly this IoT type of applications at this stage, these are running around the sub 6 gigahertz band. And people are even going for lower frequency band like 600 to 700 megahertz. So this all depends upon the type of application you are building. Many a times IoT devices require a low data rate channel. But if your application involves capturing and transmitting, say, video, then you will require high bandwidth channels. So machine to machine communication, vehicle to vehicle communication. So this type of communication require quite a good amount of bandwidth. So it depends. The bandwidth and connectivity issues are very, very important. Latency is very, very important, particularly when we go for automation, that you must ensure that once you issue a command, it is executed within a specified time. These are variety of challenges which are being faced while developing IoT and also the meeting the customer expectation. Societal issues are also to be considered because once you develop the technology, it has to be accepted and adopted by the society. So this is also a challenge. And with all these things, we started with Internet of Things, and today people are talking of Internet of Everything. So this last 20 years, and particularly last decade, has seen a tremendous growth to that extent that we have a separate IoT journal introduced by IEEE, and it was introduced only in 2014, but today it is a very, very popular journal. So you can see that sensing, communication, then network, internet, automation, everything coming together under the ambit of Internet of Things. And we expect that in near future, we'll move from Internet of Things to Internet of Everything. Thank you. Thank you for your attention.
Thank you, sir. Yeah.
So I've given a basic introduction on IoT. I would like to now pass on this session to my fellow speaker, Mr. Nara, who will talk about the industrial aspect, the business prospect, and other things connected to IoT.
Thank you, sir. Yeah. So just 1 minute, sir. There are 1 or 2 questions. Sir, can we read the question for you?
We'll take a. I can.
Okay,
You
sure,
you
sir.
post you post me the questions, because already it is 10:30. He is to start at 10:30.
Okay, sure, sir. Sure. Okay. Thank you, sir.
Okay, so should I start?
Hello.
Hello, should I start?
Yes, sir. We can start, sir. Sir, you please check it.
Yes, sir. You may please take over.
Okay. Okay.
And continue with this session.
Okay, thank you. So, I use this. Okay, good morning to one and all. It's very heartening to, have a discussion and interaction with the faculty members and the researchers for me, because see, I've been a practicing design engineer for last 4 decades.
Hello.
And, hello. Am I audible? Hello, am I audible? Oh no.
Yes, sir.
Okay.
Yes, sir, you're audible.
Okay. So just to start again, once again, good morning to all. And as I mentioned, it is very heartening to, have the discussions and deliberations with the faculty members and the researchers of this country. Why? Because, see, if I give this talk to students, I'll be only maybe sharing my perspective, maybe whatever few hundred students I've been sharing with. But if I share this perspective with teachers and researchers, I'm very sure that this perspective will be further multiplied many times in the coming years to the wider community of the students. And
hello, Firoza.
Yes, sir.
Hello, Firoza.
Yes, sir. Yes, sir. Please, sir.
Yeah, can you hear me? Any problem?
Sir. Ratnajit, sir. Hello. Hello, Ratnajit, sir.
Request Mr. Yeah, you please request and introduce Narang sir and ask you presentation.
Yes, sir. Sure, sir. Sure. Just 2 minutes. Yeah. So just 1 second.
Sure.
A very good morning to all the participants. Thank you, Professor Ratnajit, sir, for your valuable information on the topic of IoT. We would like to start with our next lecture. The next lecture will be delivered by Mr. Narang N. Kishore. Mr. Narang N. Kishore is a mentor and principal design architect at Narmix Techno Lab Private Limited. He is having over 36 years of experience in various aspects of electronics design and support consultancy. He is working in the area of design and industry, and since 1981, he has also started this organization as an independent design house in India, engaged in design and technology consultancy, providing complete design and development support to the electronics product and system manufacturing, as well as solution deploying organization. He is also supporting leading business houses in developing latest product systems and solution in the field of Internet of Things, smart grid, smart metering, smart house, smart building, smart cities. His recent design contribution have been in the field of telecom, metering, home automation, power, and convergence. So with this, I may request Narang sir to please start with the session. Thank you, sir.
Thank you. Am I audible?
Yes, sir, you are audible, sir.
Okay. Yeah. So good morning and thanks for lovely introduction. In fact, I've been into design for more than 4 decades now. Okay, but the way I see design and training, they are two sides of the same coin. So training in my own design house, I am only able to train maybe a few engineers who join me and work with me. But these kind of faculty development programs and going to the colleges, reaching out to students, faculty, researchers, gives me an opportunity to share my perspective with a wider community who can further proliferate these kind of industry-oriented perspective about technologies, about different design, to the much larger community of who are interested in these kind of topics. So I think without setting any more pretext, I think let us, before I get into IoT, I think so I changed my topic, this thing, because applications, everybody knows about it. So I thought rather than that, let us focus how do we build the competence to innovate in this IoT as well. And IoT today cannot be discussed alone, because the moment you start IoT, everybody starts talking about, look, we are putting AI, ML into our IoT solution. We are using blockchain in our IoT solution. So, and there's so many disruptive technologies which have already come in. So today, discussing IoT in isolation is not the right thing. I think we need to look at all the disruptive technology when they work together or in isolation. How do they disrupt the kind of business, industry, community, and all that society? And we need to understand how we can leverage these technologies to build some new product system solutions for the global ecosystem. Okay. So before I get into technology, I think let's discuss something which is very, very relevant today. So I think future of life on Earth, this is something which we need to look at today. A crisis as life-altering as the coronavirus pandemic naturally inspires speculation about how it will change everything. Okay. Virus which originated from a wet market in Wuhan or maybe a nearby lab has reached each and every nook and corner of the world. Okay. These days we got to learn that human desire over. Hello? Hello, can you put your mic on the mute? Hello? Okay. So these days we also got to learn that human desire to overpower, avariciousness to dominate people and land, desire to rule the universe comes to nothing in front of a nanovirus which stealthily takes just seconds to vanquish the whole humanity. Okay. Uh, so the impact that it has had and it continues to have on each and every aspect of our life is beyond words. We may not yet know it how the story ends, but we already know for sure that this pandemic has brought the greatest reversal of our times, turning the world along with its wisdom on its head. This is our free chance to unlearn and learn. Let's not blow it. So, as you might realize that it has been observed that technologies developed by human beings in the last 2-3 centuries have had a major impact on the Earth's climate and our nature's equilibrium. Some believe that they have reached a point of no return. This can have a huge impact on life on Earth and especially on the human species, and one of the impact we are already witnessing right now. However, while technology has been responsible for most of the technology also seems to have solutions for it. So, and another interesting part has been that this pandemic has catapulted two diametrically opposite paradigms to the focus of the mankind. What are those two? One is sustainability and the other is digitalization. Okay, I think today I will mainly focus on digitalization. That's part of IoT. Sustainability, I think I'd like to cover it in my next lecture on 6th of August when we have a much more time. Okay, but we're talking about digitalization and we talk about disruption. So if you remember, the Peacemaker, the ironically named advanced nuclear missile that emerged from the US arsenal during the Cold War with the ability to carry 10 independent payloads, each of which was 20 times more powerful than the first nuke dropped on Hiroshima, changed the future of warfare forever. This incident indeed created the worst carnage known to mankind and made every weapon obsolete. It changed the fundamental principles of warfare and is to date deterring humanity from plunging headfast into another world war. Likewise, this pandemic is going to have a profound and everlasting impact on how the human race evolves in the post-COVID-19 era. Today, the management of large organizations, startups, is the same did in the Cold War. Will your organization today approve a radical idea, allocate funds, and be the early adopter amidst crisis? Or will it stay stuck in the labyrinth of your legacy and perish? The global business dynamics is going to witness a sea of change in the coming times. And so is our education system also needs to, evolve. As Professor Clayton and Christensen, the scholar who introduced the disruptive innovation theory, says disruption is a process, not an event. And innovation can be disruptive relative to something else. So, are we going to be the innovator, an early adopter, or a laggard? So, it's up to us. And I think research, as we all know, starts from the education ecosystem. Education is institutions, academic institutions start the real research. But are they only focused on fundamental blue moon research, or are they also interested in applied research? That is the gap that Indian academic institutions need to focus on, that along with other fundamental research that our institutions are pretty good at. Okay, we need to, how do we now bring our focus of research into applied research so that our industry society can benefit immediately, and you can see the your research being applied in the business industry society next couple of years before it's too late. So talking about IoT, and IoT, I call it a IoT 2.0 age, because today is the days of numbers. Everybody talks about industry 4.0, society 4.5.0, and all those things. So if talking about IoT, I would call it has already come of age. A concept that originally sounded like something out of a science fiction movie. The Internet of Things is in fact a reality, and one that is bound to become even more widespread, as Professor Bhattacharya already mentioned. From being considered as one of the most disruptive technologies in the early years of last decade to coming on the verge of becoming one of the most profound technologies by weaving itself into the fabric of everyday life until it becomes indistinguishable from it. Now let's understand what are disruptive technologies. Since I mentioned these two terms, let's see what do I mean by them. Disruptive technology is the bearer of tremendous opportunity and equally a harbinger of obsolescence. Technology's impact on society and business is substantial, if not underestimated. Though product cycle times are accelerating, the underlying technologies unfold over many, many years. Within each trend are multiple enabling technologies, all at various stages of maturity and adoption. One clear example which you can relate with is artificial intelligence. You know, it was evolved like for about 4 decades back, but only now it has really become a buzzword, and it has really started proliferating in a really humongous manner. Why? Because they have been enabling technology like cloud computing. The processing power has increased that now we can run multiple complex algorithms in a reasonably short time. That's why artificial intelligence has become a reality now. Otherwise, our researchers, academicians were already working on artificial intelligence even 4 decades back. And then let's look at most profound technologies. What are those? They weave themselves into the fabric of everyday life until they are indistinguishable. What does it mean? How can something become indistinguishable? Like, let's go back into our history and look at some most profound technologies in the last couple of centuries. One of the first most profound technology you might identify as would be steam engine, then electricity, then wireless communication. And after that, I think every few decades we have been finding new communication technology, including the internet a couple of decades back, and now internet of this. What happened? Do we now question the availability of electricity or internet? Can we survive without internet or electricity today? So they become part of our life, and that's what IoT is also going to be now. Anyway, so when we talk about profound, what is technology in today's perception? Technology is anything that was not around when you were born. Everybody looks at it. So we look at it when we were born, and the young generation today looks at it when they are born. So anything done before that is not a real technology. Technology is something which has been developed in front of them in their own knowledge domain when they were born only. And I will not like to go into defining. There are multiple ways of defining IoT people, and everybody does that. Some people, look at it as like from a home point of view, one box through which you can, monitor, control all the kind of sensors, devices, controllers, actuators, like in a smart home. And then we have smart grid, smart building, smart manufacturing, and all those things where you have, smart health, all glossy, picture. Then, as a cellular operators would like us to believe that if you have a SIM card, you have mobile, you can connect anything to the internet through our mobile. Then there are so many different kind of services, use cases. There's no limit. You can Google it and find it. I'll not waste my time on it. The way I would like to define Internet of Things is very, very simple way. Internet of Things is all about heterogeneous and aware devices interacting to simplify people's life in some way or the other. If you really ask me, all these smart toothbrush and smart shoes, they are not the kind of IoT application I would like to discuss about, or I would actually consider them worthy of being called IoT application, but something which really solves some problems. Like IoT, if you really ask me, in today's time, in COVID-19, it is coming to the rescue of the mankind in a lot of remote diagnostics, remote monitoring, all these apps that you are having to see where there are people who are affected, infected, and all that. And these are some of the basic, concepts of IoT. Sense almost anything and instantly make it available online, whatever kind of sensors it may be. Okay, the smartphone revolution is the genesis today. Through it you can monitor from anywhere, anything. Then you have all kind of application. The interesting part is its ecosystem and value chain. Okay, is perhaps the most diverse and most complicated value chain of any industry or consortium that exists in the world. In fact, the gold rush to IoT is so pervasive that if you combine much of the value chain of most industry trade associations, standard bodies, the ecosystem partners of trade associations and standard bodies, and then add in different technology providers leading these industries, you get close to understanding the scope of the task. So everybody and anybody is into IoT. Everybody's impacted. But then what are the hurdles in fast growth of IoT? You see, but everybody's working in their own silo. So it's very difficult for innovation to happen across disjointed platforms and technology. Okay, creating opportunities for ecosystem partners to work across common open platform will facilitate faster innovation. And another challenge is, in this absolutely heterogeneous scenario, coming up with common harmonized standards is a major hurdle. We need to see acceleration and maturing of common standards, more cross-sector collaboration, and creative approaches to business models. However, it is high time we try to bring some semblance into this chaotic paradigm by bringing the system approach to resolve this complex problem. There is still ample scope to harmonize quite many aspects and bring interoperability among multiple competing and or conflicting standards, be it in the syntactic, semantic aspects or at different layers of protocols like network layer, application layer protocols. And we'll be discussing some today and remaining in my next lecture on 6th of August. Okay, so the technical perspective can be summed up like there are 3 layers, okay, and the key components: sensing nodes, local embedded processing nodes, connectivity nodes, software to automate tasks and enable new class of services, remote embedded processing nodes, and last but not the least, full security across the signal path. What is different about IoT, you will say? We have been doing all this machine-to-machine communication for last so many decades. What is the new thing? So these are the different device. There's so many aspects that have added now. When you're doing M2M, machine-to-machine communication in a very controlled, limited application, there are very limited aspects that work. Now we need to look at device management, access management, compute management, protocol management, data management, and even connectivity management. And given here is the there's a combination of operational technologies and information technology that are coming together today to make the IoT a possibility. There are multiple applications where real-time high-velocity data is needed, okay, and where there are some real-time high volume of data is needed. So they're all diverse use cases and applications which are making IoT as a whole as such a proliferating kind of paradigm that you cannot escape it anymore. So what is the maturity of IoT components? Okay, to give IoT the required momentum, device management platforms, cloud computing, and big data sciences in the virtual world are already flourishing and well geared up to meet the expectations of all the designers. But the physical world needs to catch up. The wireless and networking technologies need to mature very fast. We need innovative approaches in deployment of large sensors and actuator networks. So, despite so much hype and even genuine potential, the IoT paradigm has not proliferated in a true sense to its desired potential. Why? Because bringing the Internet of Things to life requires a comprehensive system approach, inclusive of intelligent processing and sensing technologies, connectivity, software, services, along with a leading ecosystem of partners. There are so many numbers. I'll not bore you with these numbers, but you can Google it and you'll find any new number. Different verticals have so much scope by 2020, these figures. I just put it for sake of, continuity. Okay. But if you really ask me, and if we do a reality check of the hypes, myths, contemporary practices, and imperatives in the shifting socio-technology scenario, okay, the most endless project at 20% CAGR for IoT. And that's a faster adoption rate than the growth of an economy. And to some, that means that things are not broken. However, the ground reality, and particularly in India, is a far cry from this rosy picture. All IoT companies are still struggling to get a foothold in the market. Profit from IoT for different nations, different ecosystems, and different stakeholders is highly dependent on the macro dynamics in their respective environments. So a comprehensive environment scan of the macro dynamics within one's own techno-socio-economic environment can help understand their impact on any IoT organization's business revenues and provide actionable insights to address the challenges and develop a long-term strategy and roadmap to evolve and mature into a sustainable IoT organization. So the interesting part is we have a lot of hype, a lot of buzz. But if you look at any company, nobody's really making money yet. They're still in the pilot phases, testing, trial, experimental basis. And what kind of competence do we need? Every true IoT application or solution, as I mentioned, needs cross-domain expertise. Internet per se has been considered the forte and playing field of software professionals. But IoT brings new challenges in the way sensor fusion, communication technologies, and energy power management of the edge nodes. Unless a designer can design the most optimized edge nodes and communication nodes, the solution shall not pass the acid test of reliable and sustained performance in the field deployment environment. So let's look at something beyond IoT, where we are going. We are looking at an interesting rising of the digital natives. The day is not far off when the kids will say, I was downloaded. No, you were not downloaded, you were born. Okay. And then we are looking at Digital India. Okay, and a lot of initiatives in Digital India, which is helping us set up a lot of infrastructure and a lot of communication infrastructure capability. And I think in these difficult times, the digitalization initiatives of Government of India will really come handy so that we are able to maintain the continuity of our business, our work, our personal life through the internet and through all the digital platforms, including the one which you're using even for learning and educating, and going from face-to-face mode to remote mode of education, business, everything. And then we are looking at, as a nation, at a $1 trillion economy. And all these aspects, and whatever you talk about, here IoT is going to play a major role in all these ecosystems. Then let's look at the digitalization also brings in a lot of challenges. There's a whole lot of data deluge. And these numbers are still very old numbers, maybe at least 3 years old. Okay, but see the kind of data that is being generated every time, how many videos were being watched, and this is all pre-COVID times, by the way. In COVID times now, everything has increased many folds, if not at least 20 times plus more. And coming to IoT, it was predicted that by 2020 we will have 3.4 million things added to internet every minute. I don't know what are the actual numbers, but these are. How do we now manage these kind of humongous proliferation of technologies, data, IoT, ICT, and AI? Then, as we all love talking about artificial intelligence, it has actually become the way of life today. Algorithms decide for every individual today. Okay, YouTube decides for us what video to watch next. Twitter decides whom to vote for, whom and where to travel. All the other social media apps help us decide what to buy. So what are they doing? They're targeting individual against target groups. Then that brings us to the impossible war between the human intelligence and artificial intelligence. Artificial intelligence, as I was talking earlier, the current wave of progress and enthusiasm for AI began in 2010, driven by three factors that built upon each other. The availability of big data from many sources, dramatically improved machine learning approaches and algorithms, and capabilities of more powerful computers. But before we talk about artificial intelligence, let us understand, because it's such a complex paradigm, people like to talk about it without really understanding what are the nuances of AI. So we need to understand what is the intelligence per se. It is supposed to be the capacity to perceive context for action, capacity to act, capacity to associate context to action. By this definition, even plants are intelligent. They can perceive and respond to the directions of light, for example. The more conventional understanding of intelligence includes being cognitive, that is, being able to learn new contexts and actions, and the associations between them. So within AI, there are a lot of taxonomies. I'll not go into details, but it's all about systems that think like human, system that act like human, system that think rationally, system that act rationally, and so on. And there are these, five categories that AI can be categorized as: logical reasoning, knowledge representation, planning and navigation, natural language processing, and perception. Okay, but when we talk about the AI, there are a lot of concerns also. Will AI outcompete us? Will AI undermine societal stability? Will AI harm privacy, personal liberty, and autonomy? Human memory has been outstripped by books for centuries. Mere intelligence is no more of a direct threat than a mere strength. So let us take a look on the what this AI is likely to head into if we do not be cautious.
We have something much bigger. Your kids probably have one of these, right? Not quite. Hell of a pilot? No. That skill is all AI. It's applying itself. Its processor can react 100 times faster than a human. The stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of shaped explosive. This is how it works. Did you see that? That little bang is enough to penetrate the skull and destroy the contents. That is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was big. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, rest easy.
This short film is more than just speculation. It shows the results of integrating and miniaturizing technologies that we already have. I'm Stuart Russell, professor of computer science at Berkeley. I've worked in AI for more than 35 years.
It's 11 hours.
The potential to benefit humanity is enormous, even in defense. Allowing machines to choose to kill humans will be devastating to our security and freedom. Thousands of my fellow researchers agree. We have an opportunity to prevent the future you just saw, but the window to act is closing fast.
I'm sorry, Daddy.
So you see, this brings us to the ethical implications of disruptive technologies Why I'm discussing this and showing this to here is because here you are the faculty members and researchers. You will have a major impact on how we leverage artificial intelligence and any other disruptive technology in the coming time. So ethical implications are very, very serious. As they say, with powerful innovation comes the need for greater social responsibility from the technology community also. Okay, so uh, but whenever people talk about singularity and other things, there's one question that comes to mind. Would a digital brain have a mind? Obvious parallels exist between the brain and digital computers. But will it have the wisdom? Intelligence it may have, but will it have the wisdom that we get with our, that's what we call a mind. So these are the kind of abstract notion that, we need to understand and keep in mind that, how do we leverage all these disruptive technologies? And whenever we are developing any AI-based solutions, we must keep these three laws of robotics in mind. Law 1, robots must never harm human beings or through inaction allow a human being to become harmed. Law 2, robots must follow instruction from human without violating rule number 1. Law 3, robots must protect themselves without violating other rules. So artificial intelligence also has to follow these kind of norms and all that. So there's a lot of work happening in IEEE on ethical, on ethics and design, ethical design. I'll not go into details. You can go through the my slide deck later on. Okay, and there's a lot of standardization work also going in ethical design. And so IEEE already has, a lot of this thing. These are standards. P7000 standards are basically on ethically aligned design, which cover different aspects of ethics in the design of autonomous and intelligent system design. There's a lot of other standardization initiative in ISO, IEC, and even independent initiatives where people are looking at when we use the disruptive technologies, IoT, AI, big data, are we being ethical and how do we control that these aspects in this? So there's a lot of work going on on ethical framework to regulate the leveraging the technology in a proper manner. Okay, so but these are kind of the things that I think maybe a little beyond the scope, but I thought it is important to at least bring some inkling about relevance of these things to the kind of research and design that we people are trying to work on using these disruptive technologies. Okay, now let's come back to this thing. And with widespread adoption of the cloud, applications and data are leaving home. So digital transformation, when we talk about, is all about data. But how data travels, it has a perilous journey. Anywhere it can be, hacked. There can be interruption. There can be trojans. There can be, hackers. So that is one of the points that we need to keep in mind whenever we are designing any IoT, ICT, any critical infrastructure system or solution. So let's take a look at who are the actors in an IoT ecosystem. We start with devices, then we have applications, and devices can be non-smart devices, can be smart devices, can be microcontroller based or maybe discrete component based, based on what kind of device we are looking at. Then now we have service providers, whether telecom service providers or IoT services providers. They have to work on these things. Then we have keep on adding a lot of actors who are getting involved. Then we have policies. We have KYC norms for IoT M2M devices in India now. Okay, regulations are there. Then we have licensing for the operators, people who provide the services. Then we have privacy issues. We need to. Then last but not the least is the security, very important. And policies impact devices, they impact applications, and they impact the service providers. And then comes the law enforcement. And policies actually empower the law enforcement agencies. And it's the job of the law enforcement agencies to make sure that everybody is delivering its own things in a proper, secure manner. Okay, so these are the kind of actors so whenever you are designing an IoT system, keep all these aspects in mind that you have to have end-to-end security in this. So what is the new challenge? It's just securing the fifth dimension, or the cyberspace as the people call it, the fifth dimension. And when we talk about security, this thing, we do not need to have a extrinsic security or security as an afterthought. It has to be security by design. When your IoT product system solution is on the drawing board, at that stage, you need to make sure that how you are going to make it rugged, reliable, and secure from very beginning. And because why it is important is because look at yourself. We ourselves today have become walking hosts. How many addresses are on each person? We carry smart watches, fitness devices, medical devices, smartphone, tablet. So, we are ourselves need to make sure that all these devices we are carrying, they are not vulnerable. Why? Because a chain is as strong as the weakest link. They say now you don't need missiles or nuclear bombs to bring down an enemy nation. I will not even go for those kind of micro and nano robots or drones. You just need a bunch of good hackers, and you can bring down even the most powerful nation on its knees merely by hacking and shutting down the critical infrastructure of the nation. Then for security, we are also talking about a lot of distributed ledger technology, whether it is blockchain, hashgraph, and so many other. Then there's so many other enabling technologies to help us in IoT, in 5G, virtualization, SDN orchestration, machine learning, robotics-based closed-loop self-healing, network slicing on transport and core layers of the networks. We are looking at ultra-high storage and compute, big data stack with all the network customers' performance and crowdsourced data. Our IoT use cases are ready for implementation, whether smart water. You talk about there's so many use cases, there's no end. You didn't talk of a particular application and there you can find a IoT use case for that. Any domain, anywhere. These are some of the low power wireless area, different communication technologies, connectivity options coming to the rescue of, designers to leverage based on the deployment scenario. How do you choose a technology based on the deployment scenario? Then, and 5G and IoT also play a crucial role in unified, sustainable, and secure, resilient end-to-end ICT infrastructure for smart cities. Because Professor Bhattacharya talked about smart cities also. So let me just give you a little look into this thing. But when we talk about different use case and application, it may require differentiated service levels. IoT covers a large range of applications, and it can be machine to machine or consumer or healthcare. These applications will have varying degree of requirement for connectivity as well as data transmission. While a healthcare device may collect continuous amount of data, or a smart appliance may not have to be transmitting continuously. We can even consider within an automobile, for an example, various systems, all systems related to safety may need continuous monitoring and real-time feedback. However, an infotainment system of a vehicle may not have, may have very entirely different requirements. Environmental applications such as clean air, water monitoring system may have another set of requirements. All these applications will transfer varying degree of data, some large, some small, and others will be a mix of these and at various intervals versus real time. It may be important to understand these requirements from a system perspective and offer differentiated class of services within a network that provides the connectivity. So there are multiple technologies who have helped us in the business evolution from time to time. Okay, from 2G, 3G, 4-bit to now we are looking at 5G, this thing. And you will see, as the technologies evolved, multiple use cases and applications started becoming a reality. So right from the current this thing to on road to 5G, and with 5G, we'll be able to do much more kind of application use cases. So IoT will be much more proliferated when we have 5G in place. So 5G, just touching a little bit on that, it talks about three different aspects. Basically what it talks about is enhanced mobile broadband, ultra reliable low latency communication, and the massive machine, the massive IoT basically. Okay, but when we are moving from 4G to 5G, what are the major difference from a user's point of view? That must be something other than faster speed. For example, higher number of simultaneously connected devices are expected. Okay, higher system spectral efficiency, data volume per unit area, lower battery consumption, lower outage probability, that means better coverage, high bitrate in large portions of the coverage area, lower latency, higher number of supported devices, lower infrastructure dependence, deployment costs, higher versatility and scalability, or higher reliability of communication. Then 5G in smart infrastructure, we are talking about so many verticals: automotive, transportation, healthcare, energy, manufacturing, and media. Most important 5G infrastructure performance requirements are a latency below 5 milliseconds, support for device densities of up to 100 devices per meter square, and a reliable coverage area. A successful 5G deployment will integrate telecommunication technologies, including mobile, fixed, optical, and satellite, both GEO and MEO, range of their satellites. So what are other expectations? Data rates of tens of megabits per second should be supported for tens of thousands of users simultaneously. 1 gigabit per second to be offered simultaneously to many workers on the same office floor. Several hundreds of thousands of simultaneous connections to be supported for massive sensor deployment. Spectral efficiency should be significantly enhanced. Coverage should be improved. Again, same this thing. Okay, and latency should be really reduced as well. So, if we could sum it in three different bullet points, that a super efficient mobile network that delivers a better performance network for lower investment cost. It addresses the mobile network operators' pressing need to see the unit cost of data transport falling at roughly the same rate as volume of data demand is rising. It would be a leap forward in efficiency based on the IoT demand attentive network philosophy, a super fast mobile network. So we talk about super efficient, now we talk about super fast, and then a converged fiber wireless network that uses for the first time for wireless internet access the millimeter wave band 20 to 60 gigahertz band, so as to allow very wide bandwidth radio channels are able to support data access speed of up to 10 gigabits per second. The connection essentially comprises short wireless links on the end of the local fiber optical cable. It would be more of a nomadic service like Wi-Fi rather than a wide area mobile service. There now, if you look at standardization about IoT, which Professor Bhattacharya talked about, so different standards work at different layers. So these are typical layers, and how do the standards make? There are multiple technologies in this way. So, but here there is a basic gap area where we need some kind of standardization. But even at the lower level, if you see, there are multiple technologies which do not work seamlessly together. Okay, so how do we work in a harmonious way? How do we make them work in a harmony? If I have time today, I'll discuss that today. Otherwise, I'll discuss that at length in my next class. Okay, so these are the areas where you work on for the interoperability and standards. Then we have proximity radios, as I mentioned, higher level, proprietary and others. There are so many standards, so many things. The real beauty is that there are so many standards to choose from. Okay, and this is a typical IoT architecture and protocol for different. So you have a processor where you have different kind of communication. One is for the OMADM is for device management. MQTT CoAP is an application communication protocol. Then we have low power applications. We have radio modules. Okay, then we have network operators. We have cloud servers. The challenge here is device management is not an option. Every processor, every application needs to be configured, upgraded, and monitored always. Each protocol must be secured and synchronized. You can't trigger an update with a protocol while you are rebooting the device using another. M2M IoT is not a simple problem. Security and provisioning are really the hardest ones. Try hard to reduce the number of protocols to make your life easier. There is no single protocol to rule them all. Every protocol is nice and specialized. So, beyond these, what are the challenges in the fast growth of IoT? The challenges that inhibit the IoT-related standards and hence a robust rollout of IoT services are security and privacy issues. Not that security privacy measures are a lot of times at odds. So security and privacy, they are always at odds to each other. Endless IoT ecosystem, endless potential types of edge node technologies. Okay, then high fragmentation of today's IoT connectivity solutions. Lots of legacy systems that will be now part of IPv6 networks with or no minimum existing coexistence or interoperability plans. Partnership between heterogeneous and diverse industries and defining the associated business models involving multiple stakeholders and service providers of some of these legacy systems in number. Management and provisioning of various network devices and applications and services, and the network capacity planning that comes with it. Regulatory issues that will hinder deployment on a worldwide basis. Special needs of industrial-grade product rollout and with long-lasting requirements in the field that require future-proofing of any standard recommended. Slow development of the IoT services market, partially due to lack of future-proof standards. So if you really look at the open infrastructure characteristics, these are some of the characteristics that are bound to be there, which are missing in the IoT ecosystem today. Shareability, that helps us economy of scale and minimize duplication. Ubiquity, readily utilize infrastructure anywhere. Integrity, high level of manageability and reliability. Ease of use, logical and consistent rules to use infrastructure. Cost effectiveness, value consistent with cost. Standard, define how basic elements interrelate. Openness, support multiple users and vendors, not proprietary. Secure, system must be protected. Scalable, low or high density areas and phased implementation. Role of standards is very critical in open architecture of any particular aspect. And as I already mentioned, a chain smart but not secure. Currently, the weakest link in the smart infrastructure signal chain is our smart end node. A robust communication and IT infrastructure shall be no good if we continue to use the devices which are not equally secure. So the new imperative for the design community is to design smart and secure phones, sensors, devices, or instruments. A few more macro level paradigm challenges. IoT is supposed to be a global neural network of networks, becomes unmanageable at times. Homogeneous network of heterogeneous devices. We talk about industrial IoT versus consumer IoT, services versus applications, infrastructure versus enterprise versus homes, and then end-to-end security in the signal chain. All these are the challenges that for successful proliferation of IoT, we need to resolve in one way or the other. Okay, so problem statement. Exponential growth in consumer-facing application. M2M IoT application poised to explode, will drive order of magnitude increases in bandwidth consumption, provisioning, and control actions. Many applications are poorly adapted to the constraints posed by wireless networks, but wireless is essential in the bridging of the digital divide, especially in rural areas. Protocols that manage the services and devices efficiently are essential if the promise of untethered applications is to be fulfilled. How do mobile operators deploy networks that efficiently serve populated areas with their onslaught of IoT devices, as well as rural areas that need both high-speed data and M2M IoT devices, services? So that brings me to a little interesting scenario: smart cities. Okay, how does IoT help in transforming the urban landscape? Okay, if you really see the smart transformation, every aspect, every ecosystem, whether smart cities, smart grid, smart buildings, smart factories, now they find themselves making three classes of transformation. Improvement of infrastructure to make it resilient and sustainable. Addition of the digital layer, which is the essence of smart paradigm. And business process transformation necessary to capitalize on the investment in smart technologies. So how do we accelerate and de-risk the smart city transformation journey? So this is some slides from our smart city mission. These are their approach towards addressing the three core issues of ease of living, economic ability, and sustainability. And these are some of the strategies they are planning. And you see, the interesting part is at the core of it is all data. And data will come through IoT ecosystem. So there are a lot of initiatives from the mission, standardization on different aspects. I'll not go into details right now. To refer to these. Okay. But so what is the genesis of a smart city? The way I would like to define a smart city is that in a smart city, sustainability is the true destination. And resilience is its core characteristics. Smart is merely the accelerator, and standards are the chromosome of smart infrastructure. And we'll go a little bit beyond in this. Okay. So the two underlying philosophies that I've been talking about is standards are the chromosomes of smart infrastructure. And as people say, data is the oil of 21st century. then my question is very simple, that then what is big data? Because we are going to generate a lot of big data in the smart cities and through IoT system solutions products. So then big data is the crude oil. Why? Because it needs a lot of processing before it actually becomes usable. And if you look at the smart city, the features of smart city, there are 24 features identified by our Ministry of Housing and Urban Affairs. All these things you will see ICT and IoT opportunities are there in all the areas. That's why IoT and ICT is very, very critical for smart cities deployment. Now, let's take a look on the, a sample Indian business case of next 5 to 10 years in smart infrastructure. Okay, this is my back of envelope calculation a few years back. Say 250 million smart electricity meters are going to be procured and deployed under National Smart Grid Mission. Okay, all these smart meters are going to use 250 million communication modules and minimum 500,000 gateways or DCUs. Smart street lights are going to use about 100 million communication modules and at least 500,000 of the DCUs. Smart buildings are going to deploy at least more than 50 million smart sensors and at least 100, 200,000 DCUs or gateways. Automobiles shall use at least 100 to 200 million communication nodes for vehicle operation maintenance, vehicle to infrastructure and other telematic applications. Similarly, if you start adding all the critical infrastructure and civic infrastructure use cases, we come to about need of say 5 to 10 billion communication modules and to be integrated into this thing with a 10 to 50 million gateways that shall be needed in the nationwide critical infrastructure, okay, next 5 to 10 years. This number, if you see, is more than mobile, 5 to 10 billion communication modules. Now, but what is the problem? The problem is this whole market is really fragmented. The standardization in this ecosystem can bring in really make these communication modules and technologies really low cost. And we'll be discussing that at length in the next lecture. Today we may not have that time. Okay, so and what is the irony is that we realize that smart home, smart building, smart city, smart grid, they're all being pursued in isolation from each other by the respective stakeholders. In fact, they form a very tightly interwoven and homogeneous confluence of similar technologies being applied in different domains for a common cause of making our planet Earth smart, green, and secure. All the applications today live in silos. And there's a common understanding is a real big deal in cities. Different stakeholders do not understand each other. They are working in silo, and you see the result, the way a railway track started from 2 different sides. How does it integrate? And the cacophony or symphony. The beauty of standard is that there are so many to choose from. So that is creating a cacophony rather than a symphony. So what are the standardization imperatives? Standards and even SDOs are not at the forefront of city planners, utilities, or even users' mind. There are misconceptions on what standards are for, and the case for use of standard has not been made. Liberalization and markets have a lot of great virtues, but they cannot create their own conditions of existence. They must be designed. And one of the very interesting arguments I always, find here from the researchers and startup ecosystem is that standards block innovation. Is it correct? I don't think so. The real truth is, if you talk a proprietary kind of way of doing things, like my flavor of, my shade of green, my shade of blue, that is your innovation, then I'm sorry, those are the kind of things are not innovation. And that is the kind of innovation standard will block. But if you really ask me, in such a complex and heterogeneous paradigm, standards actually define the contours for structured innovation. They define that this is the way ecosystem is going. So if you develop your product, system solutions, your protocols, your this thing within these contours, you'll have a big market to work on. Okay, so these are the two things that even this is a challenge for harmonization, is a challenge for the SDOs also. Now let's take a look at this is a typical smart city ICT architecture in a very simplified view. We have multiple layers where sensors, network, and all these data is going and ultimately. On the right, left and right, you'll see the cross-cutting issues of operations, governance, security, and integration of different aspects. And if you see from data or information flow point of view, we can put it in 7 layers. Okay, you see on the right hand side we have layer 1 to 7 devices, communication protocol. Then we have cloud infrastructure, big data, reporting, mining, and on the layers 6 and 7 custom app builds and transformational decision making and this thing. On the left hand side, if you see, you find these, the nature of data ingested, like data at rest, data volume, data velocity, data veracity, and nature of analysis: cognitive, prescriptive, predictive, descriptive, and discovery. But so these are, and if we map these 7 layers with a smart infrastructure, the way our Ministry of Housing and Urban Affairs map 4 pillars: physical, social, economic infrastructure, what we realize is that all the applications and everything, they only change at the top 2 layers: application, people, and process. All the below underlying 5 layers can remain the same, or at least should remain the same. So that gave us a new way of looking at things, is that why can't we, club all the common part and make a unified architecture where we have, all the diverse things converging into one common, this thing, and then again, diversifying into individual use cases. And for that, then we are built up a smart city platform based on all these latest IT technologies. We have a data layer architecture, which is very, very granular, which is looking at all kind of, data knowledge, and even leveraging the, AI in the, for, getting actionable insights or creating new data sets. And then we have last mile communication, which we are standardizing. I'll go into detail in the next session. Okay. And so what we look at is unified ICT abstraction. You see, everybody talks about hourglass, whether you talk about internet hourglass architecture or 1M, 2M people, they talk about you converge on a 1 layer and then again open up. But today, this thing, we need a much longer stem. So we have developed a classic saucer champagne glass architecture model where this common part is much longer. Why? Because we have 4 aspects. We have unified glass communication, this thing, standardized gateways, common service functions, and urban open stack that are common. Okay, below. So this is the new architecture that in India we have developed for our smart cities ICT infrastructure, leveraging all the new paradigms. So what this talks about is that with a wide flat bottom base depicting the multitude of field devices and sensors, the saucer-shaped bowl on top depicting being filled with an ever-increasing spectrum of city applications and citizen services. The long stem depicts all the common layers, that is unified last mile communication, common standardized gateways, application of vertical agnostic, common service layer representing common service functions in the gateways as well as in the cloud, and the smart city middleware and city data reservoir in the cloud. It is the long stem of the champagne glass model instead of the short and narrow neck in the hourglass model that brings the comprehensive harmonization, standardization, and interoperability in the architecture, leading to optimization in operational efficiency and life cycle cost of the ICT infrastructure in any smart city. What is happening? Currently, we are having 15, 20 different ICT infrastructure in a city for individual for each service. If we have a common ICT backbone for all the services, specific infrastructure and utilities and services, imagine the kind of reduction in capex and opex will be there, as well as it will bring down the carbon footprint of the ICT infrastructure. And last but not the least, what it will bring to the table is, since it is a well architected, unified infrastructure, it will be easier to secure it and make it more resilient. So there are a lot of further approaches. I think my time is more than over. I have to overshot. There's a lot of other things which we can discuss, but we are working on. So I think I'll not go into that. But let's understand whether it is urban landscape transformation or whether we talk about IoT proliferation. It's neither an easy nor a set of linear requirement, but a complex and iterative process that requires careful consideration and cooperation with all the diverse stakeholders of the ecosystem. I think I'll stop at this moment, unless I have to think. And I think rest I'll cover in my next lecture. Will that be okay?
Yeah, thank you, sir.
I think I overshot my time. Am I right?
No, sir. Perfectly fine, sir. We are supposed to end the session by 11:30.
Okay, great. Then I'm
Sir, there is a question for you. So can I read the question for you, sir?
sure, sure. Sure.
Are the current AI tool enough for achieving goal in WSN?
See, the interesting part is when we talk about wireless sensor networks and we talk about AI, tools are, see, AI is very, very processing intensive. You need to keep in mind, you know, and do we have the kind of power? Do we have kind of bandwidth to allow that? Now, this is a real dichotomy that we need to address. A lot of people are here talking about even using blockchain for, security in the wireless sensor networks. But you need to keep in mind in the wireless sensor networks, we are looking at very, very constrained bandwidth, constrained network, constrained power, constrained processing power, constrained energy and power management issues. So we are working in a very constrained environment. If we are looking at constrained environment, how do we, do that? So this is where we need whole lot of, so tools are there. The real challenge that we need is how do we have the lowest processing power footprint of the AI, whatever intelligence that we need. So when we talk about all this infrastructural, this thing and leveraging all the technology intelligence. So I'll tell you the way it is that even for the smart cities, initially what we are doing is we are trying to do all the maximum intelligence processing, database management, everything in the cloud. Once we have that, we know all these things are done. Then we gradually migrate to the edge nodes like the gateways and all that, whatever intelligence, whatever this thing as per use case, as per processing capability, as per bandwidth available, we need to then have a right kind of a balance that what can be shifted to the edge in the network and what still need to remain either at the end device level or at the cloud level. This is a real balance that a system design aspects will govern, not you and me or simply by over ambitious thinking that I'll apply AI to my wireless sensor network. Given such a blanket statement may not actually help us solve the problem really. Does that answer the question?
Yes, sir.
Okay.
Yes, sir. Thank you, sir. Yeah. May I request Ratnajit, sir? There were a couple of questions, sir. Yeah.
Hello. Firoza, can you hear me?
Yes, sir. Yes, sir. I can hear you, sir. Please, sir.
There were quite a good number of questions. So let me try to answer one by one. I start with one about communication technologies for IoT only. Somebody raised this question. Yeah. You can use our cellular network, cellular communication technologies. And the main issue is the cost. Many times, if you go for the license spectrum and use it for IoT, it becomes costly. People try to use unlicensed spectrum for IoT type communication. And again, there are issues related to range. For short range, in my lecture in detail, for short range, you can use technologies like Bluetooth, Wi-Fi. For long ranges, there are some technologies being developed like LoRa, Sigfox. These are the communication technologies which are under development and that can cover ranges like even up to 10 kilometers. In most of the IoT applications where we use the sensors, the bandwidth requirement is less. Until and unless we are streaming videos and other things, it is only the data this being sent by the sensor, then the bandwidth requirement is less. So there are some proprietary technologies, communication technologies, which are being developed targeting IoT application. And also there are technologies already available, including our cellular communication wireless technologies, those can be utilized for IoT application. It is the choice is with the user and the designer. I'll discuss in detail in the lecture that we have day after tomorrow. The next question is about the packaging. Yes, this is a, there are a lot of issues relating to the packaging of IoT devices, particularly the sensors. The packaging has to be very robust because sometimes these sensors may have to work on harsh environments. Not only harsh environment in the form of temperature, uh, the humidity, rain, like that, but also in harsh electromagnetic environment, because in very, very congested urban areas, we have a lot of radiation and other things, and the sensors need to be protected from this type of unwanted radiations. So packaging is very definitely very critical, particularly for the sensors. And of course, this will be discussed to some detail. Tomorrow we have a session on sensors. The packaging is an issue. Power dissipation is an issue. Lifetime is even more critical issue because 5G was mentioned by Mr. Nang, and there we are expecting a tenfold increase in the lifetime using a small battery button type cells. The sensor can last for years. So this type of performances are being envisaged, and people are also talking of nowadays wireless energy transfer, powering those devices by transferring uh, uh, energy while communicating with such devices. So many issues are coming up. So power dissipation should be as less as possible. Lifetime of the devices should be as high as possible. And also the wirelessly, if these devices can be powered wirelessly, this research is on. This will solve many of our problems. The next question, let me just check. With growing technologies, there is also growing concern about the security and data protection. See, security threats come into one is the physical threat, because when you actually install the sensors and other things, they should be, first of all, secured from being uh, damaged by intentional or unintentional ways. So physical security is one thing that has to be provided. And particularly if you are putting the sensors in hazardous areas, there the security becomes even more, physical security of the devices become even more important. Apart from that, the security of the communication, you should ensure that the data sensed by the sensors are not altered by some, I should say, intruder, or the actuators, if you are uh, putting, then the action of these actuators are not altered by the intruder so that the system function properly. And there are layers of security which is usually placed, and this is part of securing how the data is captured, how the data is transmitted, securing how the data is processed. Everything will be discussed in a separate class. We have a full lecture module by one expert from IIIT Guwahati who works specifically on the security aspects of internet. So I don't think I'll be able to make much contribution to this question. Finally, there was another questions about the ubiquitous computing. See, traditionally, our computation is to be done at the end nodes, which is either a laptop or a desktop or some other computing devices. But with the new paradigm of ubiquitous computing, now we have computation taking place even at various stages of the network, and even the devices, sensors, and the routing devices all will have capability to process information, and computation becomes very, very distributed over the entire network. So I hope I've been able to answer the queries raised by you, and thanks for your interest in IoT and raising these questions.
Thank you, sir. Sir, there are a couple of questions for Naran sir also. Sir, may I?
Sure.
Yeah. There was one question from Neha Kashyap about the security of IoT data that already Ratnajit sir has addressed. So we are moving to the next question. What is the relation between the IoT and ML?
Yeah. So IoT and ML, or I think AI or ML. Okay. Uh, so artificial intelligence is about what? Well, machine learning basically helps you, process the data to enable your artificial intelligence. Actually. Okay. So machine learning is a tool to achieve the artificial intelligence, the way I understand. Okay. And they are always used in conjunction, so that's why people get confused. They're not parallel. In fact, ML is a subset of AI, big data, and a lot of other discipline algorithms and all those subjects that you study. So you leverage that to build in the comprehensive artificial intelligence based actionable insights or decision making or whatever. Does it answer the question?
Thank you, sir. So the next question is how we can differentiate IoT and WSN.
Yeah. Oh, yeah. That's a very interesting question. So I'll tell you, WSN is a very, very legacy term which is used by researchers. So wireless sensor network was the initial term, in fact, before the IoT, where it was only envisaged that we could just create network of different sensors. So IoT is a more comprehensive paradigm of an evolved avatar of, you can say, WSN or wireless sensor network, because see, it's not simply a network. We are looking at a complete application, complete solution, and complete ecosystem of which goes beyond network. It goes in a lot of data and information processing, providing you actionable insights, giving you a lot of control. So sensor WSN was the first, or you can say primitive avatar of IoT only. They are not two different things. One was the basic theoretical approach, academician's approach to the network device, this thing architectures. Now which has evolved into much comprehensive paradigm with lot of application, lot of all different kind of connotations into the WSN paradigm.
Thank you, sir. The next question is, are communication between sensors relevant in the study of IoT physical layer, specific or higher layer?
So the communication, so there, I think this I'll be discussing in detail in my next lecture on 6th, but to give a short answer, the communication is the protocol is a stack of all the 7 layers. 5 is basically to connect the physical medium. So that's a communication technology itself. When we talk about different technologies, whether Wi-Fi, cellular, 15.4, LoRa, and all these, they are basically Phi and MAC based. In fact, the layers above, they help in packaging the data or the application layer to all that in a proper structure frame, which then through Phi layer gets transmitted into the environment and reaches from one node to another. So they all have their own relevance, but direct contact from the within the devices, it's Phi. Rest all layers remain at the back, and that's what basically brings the difference between the throughput and all those. But what we are now trying to do is, which I'll be discussing in my next classes, we are standardizing the L3 to L7 layers of the OSI model, okay, and So, and with critical interface, which can integrate multiple communication technologies and their respective 5 Macs, which they are, because they are closely bounded together among themselves, so that your for a user for application level, L3 onwards, your data frame, packets, application, everything remains same. And based on the field condition, you can use different communication technologies seamlessly.
So the last question is, which is the IoT journal that you were talking in the presentation, like the reference of the IoT journal?
So IoT journal, there's a IEEE, I think Professor Ratnjit mentioned, but so there's a IEEE IoT magazine. There's an IoT magazine of IEEE, and I'm the standard column editor there. So there we have, so we are always collecting lot of applications, use cases, research, more of practical aspect. The focus of this is not a journal. This is a magazine, IoT magazine, which is more about the practical applications of IoT. We capture a lot of this thing. In fact, our new COVID-19 special issue is coming in September, where we will be presenting a lot of articles about how IoT has helped in combating the COVID-19 situations in different areas.
Okay, so thank you, sir. Almost we are done with the question answer session. So there is a last question: how and where to learn protocol for IoT application? What is specific emerging topic in IoT smart home area?
Yeah, so this is a fully loaded question. I think it needs a very, very long answer, which I'll be addressing in my next class. But to give you a very quick this thing, so application layer, see what we need is, really we need to have in IoT, we need to have our, most of use cases are sensor and control automation based. So they have very, very low volume of data, low short. We need to have very compact, efficient packets. Payload should be very efficient, yet it should be secure. Then how do we package it? How do we do the data modeling? All those aspects, which I'll be discussing within that, which constitute the complete data frame at the application layer. They are the relevant standard, which is mostly in the ITF RFCs. Most of them are there, and with them you use. And then what was the question was? What was the second part of the question? Can you say again? The second part of the question.
Yes, it is. What is the specific emerging topic in IoT smart home area?
Yeah, smart home. So, so the smart home area, basically, so the problem has been, we've been hearing about smart home for last 3 decades at least, since 1990, I remember. Okay, but it has not proliferated. Why? Because everybody develops their own proprietary solution. So the challenge in the smart home area is, how do we make devices interoperable? That is the area where we need to make people work. See, if you take an example of electrical appliances, or the IT appliances, you can go to the wholesale market or retail market, pick up bulb of any brand, it will fit into socket of any brand. You can pick up an a plug and socket of any this thing, they can interplay. They are compatible. And whether you pick up even switches and sockets, and they'll fit into any switchboard. All that is standardization. Like in IT equipment, you can pick up anybody's modem, it will work with any laptop. You can pick up anybody's laptop or this thing, mouse and all that. Unless we get this kind of a plug and play kind of interoperability between smart home devices, appliances, smart home will not become a reality. It will always remain a very, very, pilot based kind of experimental base. And then the problem is why consumers are very reluctant to going for smart home, because it is proprietary design control, standard driven, proprietary control. So that means if I make my home smart and buy a solution from X vendor, I'm not dependent on him. I'm slave of him for the lifelong for my product life cycle. I'm to depend on him. I cannot interface it or plug and play with anybody else, any other smart product. So whatever products that vendor gives me, I have to work, because they will be only interoperable. So that are the challenges. So wherever there are challenges, there are opportunities. Okay. Now you see the interesting part is all these Alexas and all these, they have made look smart home a very easy reality, but the ground reality is still far off. Okay. We need to make the end devices interoperable. And that is where our, I think, wireless communication protocol will play a major role. And I think we'll discuss that more in the next class. Yeah. Does it answer the question to some extent?
Yeah.
Okay.
Yes, sir. Thank you, sir. The participants have given thank you note to both Professor Ratnajit Bhattacharya, sir, and you, sir. And so there are a few questions about the learning, the protocols of the IoT protocols that will be used. So you already addressed that you will be discussing the same in the coming sessions, sir.
Yes, I will.
Yeah. Yeah. Okay, sir. Thank you, sir. Thank you, Ratnajit, sir. I think all the answers are already, questions are already been addressed. So with this, we will conclude today's session, sir, the first half of today's session. So now we will be having a 15 minutes break and we will start with the next session from 12 p.m., sir.
Thank you.
Yeah. Thank you, Naran, sir. Thank you, Ratnajit, sir.
Thank you. Thank you very much.
Thank you.
Thank you, sir. I request all the participants to please connect us by at 12 o'clock. No need to disconnect the Cisco event. You please join us by 12. We will start the next session, the lecture of the next session. Thank you.
Firoza? Firoza?
Yes, sir.
So I will introduce Professor Nandi. Huh?
Okay, okay. Yes, sir. Thank you, sir. Yeah.
Okay.
Firoza,
Yes, sir.
can I share my slides?
Yes, sir, sir. We have given a break of 10 minutes, sir, but you
No,
can
no.
share your.
Yeah,
You can
testing.
Yes,
Yes,
sir.
sir.
Yes, please, sir.
The
We have already given the privilege.
You cannot take break.
Yes, sir. It's very difficult for Firoza and Pulavi to take a break.
Yeah. Bharat, you are still around?
Yes, sir. I'm still
Great.
listening
So
everything, sir.
how did the first session go?
Sir, it went well. It's a
Okay.
introduction part, and it's really informative, and the people will really understand that what is IoT. Then that all the definition, basically a technical session is there, and that is the session, the technical definition. So I hope the people who are working in these areas, they will really getting knowledge.
Okay, that's the purpose of arranging and spending our time, that people should be more motivated to pick up research problems and
Correct, sir.
yeah.
Because we are here giving the spectrum, basically, like where they
Yeah.
can find out the problems. Like we are dealing the whole spectrum, and in which the people that who are more related to that, they will pick up their domains and then start working.
Yeah.
That's there.
Sorry for interrupting, sir. Sukumar Nandi, sir, can you, sir, share your content?
I am not able to click that share button.
Sir, 1 second. Yep. Pubali, can you please
yes, sir.
check? Yeah.
Sir, like the presentation rights has been given to you. So you have to click on the share tab on the top of the screen. So you'll have the third option as share.
Option share.
So file, edit, share.
I'll edit share. I don't have.
Yes, sir. On the top of the screen, the third option, the tab, it is showing as share.
Let me see. I'm not able to find in my place.
You go to the top of the screen, not at the bottom. There is another ribbon where you have share, but not this one. At the top
Correct.
corner.
I am at the top.
Yeah,
Yes, sir.
top,
At the top
left corner.
sir.
Left corner. Acha.
So the first option is as file, second as edit, and the third option you will find the share button.
I am in WebEx. I'm not able to find anything because my system is not showing anything.
Okay.
Sir, at the bottom also you are not getting the symbols like mic, video, share at the bottom.
No,
There are few.
I am not getting. That's why I am talking.
Where
I am getting.
Professor Nandi,
Yes.
in that case, can you share your slides to Firoza so that she can just share it from her end, or Puvali?
No, I want to control myself.
Yes.
Oh, in that case, they will give the control to you.
Sir, can you just give like a photo of your screen so that we can see it's like why it is not coming?
Photo of the screen.
Screen capture.
So you can
Screen
just share
capture.
me on WhatsApp. Yeah.
Yes, sir, in WhatsApp also you can share it, sir.
1 minute. I try to join in other ways, but it was not enough. So.
Sir, do you have Linux system, sir?
I am running here. What it's called? Mac.
Okay, okay. Pupali, I think so. Like we faced some issue related to the Linux system. Is it maybe the same case?
Yes, ma'am. Might be, ma'am. We can confirm only after we see Sukumar sir's screen.
Yeah. Okay. Just one second.
This is good. Okay, let me come out. Why it is working from the not directly from WebEx? This WebEx app. It is working from web only.
Sorry, sir.
Let me try another way.
Okay, sir.
I am not getting sharing option, man. I don't know why.
So
Hello?
now are you getting? Hello, yes, sir.
Now
So
I
now
join
please
again.
check. Yes, sir. So we have given you the rights to share your screen.
Oh, it's not yet. I have rejoined in. It's not showing. Okay.
Yeah. So at the below of this, like at the below of the screen also, so you're not getting the ribbons of muting, unmuting, video, then share content.
Share content is not working. That's the basic thing. Their content is not working.
Yeah, I think so, Pupali. It is the same case that we faced in the last FDP related to the Linux system. So either we can run the presentation slide on behalf of sir, or can we have in the mobile, through mobile also, can we do this, Pupali?
It might get difficult from mobile, ma'am.
Okay. So can we have your slides, sir? We will make the slides change from our end. So for today's session, today we will try to resolve, like we face the issue with the Linux system also, like when anyone is joining as a panelist in the Linux system, he's not able to control, like this is one feedback we have already given to Cisco. So sir, for the next session, we will make the arrangement. So for now, sir, can we have your slides so that we can make the changes from our end?
1 minute. I'm coming to your place. No problem. Within 2 minutes.
Okay, 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 sir.
Okay.
Firoza, can you hear me?
Yes, sir. Yes, sir.
Yeah. I got disconnected in between because I changed the network. So,
Yes.
Professor, they could solve the problem?
Actually, sir, was trying to connect by the MacBook. So, sir, actually, with Linux system, we face one technical issue that if someone connect by the Linux system, then the slide share option is not there. I think so. The same issue is with the Mac. So, I think so. Sir is joining with a Windows system, so it will be working.
This is exactly the compatibility issue we are discussing, standardization issue.
Yes, sir.
I also could not join through our Wi-Fi network. There was some issue. Then I'm connected to this session through. I'm using my mobile as a hotspot, and then I connected.
Okay. Thank you, sir. So in the meantime, when all the participants are joining, can we make the announcements, sir? Few announcements to the participants?
Yeah.
Yeah, I request again, we are requesting to all the participants to please log in the event by the email that you receive in your respective registered email ID, because that by that email ID we will be tracking your attendance. We are getting a lot of query related to the same. We request you that there will be no separate attendance sheet being given or attendance link will be given to you all. Attendance will be monitored by your login detail by which you will be logged. So please make sure that you are registering, you are joining the event by the email ID. Secondly, there are few queries related to the YouTube link. We are giving the YouTube videos only for your reference. There will be no separate attendance maintained for the YouTube viewers. So I request you all to please connect with the event. The YouTube videos will be there for your reference. You can refer to the videos. And if any colleague of yours, as we are getting a lot of requests for joining the program after closing the registration link. So I will request you please refer your colleague to view the YouTube link, the live videos that are being displayed in the YouTube. Because if you join the YouTube channel, we will not be able to monitor your attendance. So these are the two announcements. I request you all to please, please, please make sure that you are connecting with your registered email ID and you are joining it by the WebEx event. Thank you.
Puvali?
Yes, sir.
Professor Nandi could join?
No, sir, not yet, sir. We're trying to contact him, sir.
Sir, actually just received a call from Nandi sir. Nandi sir is connecting by Windows machine, sir. It will take another 5 minutes of time. Actually, sir thought that we are in office, so sir was sir wanted to join us from our office, sir. So,
okay.
Okay. Thank you, sir. Just sir, 5 minutes, sir. Dear participant, due to some technical issue, we will be starting our session by in another 5 minutes. Sorry for the inconvenience caused.
Firoza. Firoz.
Yes, sir. Yes, sir. Hello, sir. Yes, sir. Please, sir.
Actually, Nandit were operating from E&ICT office. You went there and back.
Yes, sir, sir.
So he has now managed a Windows machine and he's joining. Just time.
Yes, sir, sir. Yeah, sir.
Yeah. Please be there for a while.
Thank you, sir.
Walker, we did not anticipate that there will be an issue with a Pubali.
Yes, sir.
Yes, sir.
Yeah, so we should learn from this lesson. Next session onward, at least beforehand, you should check these compatibility issues. Huh?
Yes, sir. Sure, sir.
Anyway, Professor Nandi still could not join, or he has joined?
No, sir. No, sir. Not yet joined, sir.
So today afternoon itself, you check with Dr. Rishikesh. Huh?
Yes, sir. So we'll drop a message after Sukumar, like sir starts the session. So we'll do that, sir.
Tomorrow, who are the speakers?
So tomorrow is a Rishikesh, sir, and from we are having hands-on from Uniconverge.
So both the things you check today itself. Huh? There should
Yes,
not
sir.
be any
Yes, sir.
before you close.
Yes, sir. Sure, sir.
Yeah.
Thank you, sir.
Unaffected. No. Actually, we are having a session.
Right to you. Okay. You. Oh, now share button is working. 1 minute. Now share button is working. Great.
Yes, sir.
Thank you, sir.
Yes,
Great,
sir.
great.
Thank you.
Great. Okay, let me share now. Right? What happened? Again? Wait, what happened? Wait. Okay. Share screen. And, yeah.
Yes, sir. The slides are visible, sir.
Oh, so
Thank you, sir.
after a lot of difficulties. So you start. I am arranging rest of the things. Okay, start.
Yeah.
Sorry.
We
Sorry.
are really sorry, participant, for due to some technical issue, we are delayed by 10 minutes, so we will be extending this session. May I request Ratnajit sir to please, Ratnajit sir?
Back and you can hear me.
Yes, sir, we can hear you, sir.
Okay.
Yes, sir.
So we start second session, which is architect and also about the introduction about the protocols, particularly MQTT, MQP, COAP. So there are different protocols. And this session, the speaker is a distinguished professor of computer science. He is a very senior faculty in the department and engineering IIT Guwahati, Professor Sukumar Nandi, who has been with this department right from the inception, and he areas fellow of the INE, and he is a well-known researcher not only in the country, abroad also. And we are very fortunate that Professor Nandi has accepted our invitation to speak on this FTP. I am sure the participants of this FTP will be benefited with this interaction with him. With this simple introduction, because already we are delayed, I hand over this platform to Professor Nandi and invite him to deliver his talk. Thank you.
Thank you. I am sorry for late because of my machine was not working. I tried with Mac, then Linux, then Windows, then back to Mac, and Mac is working now. Okay, you can see me. By the way, we are teachers, so we like physical teaching. Then we converted into video conferencing level teaching. Now we have to give a lecture, monologues, 1.5 hours almost, without looking anyone listening or talking or whatever doing. So it's a very tough job for us. And coming to the IoT, these slides I prepare from internet. It is not my own slides. It's a cut and paste from internet and prepared by one of my student. I edited a little bit. I kept it, some of the sources wherever I can keep it. Rest other I have not kept it, but if I have not kept it, if you found in the website, let me excuse that part. IoT architectures I have to speak as IoT architecture, if I look into it, it's very difficult to define which level of architecture I have to talk. Because architecture comes in every level. It depends on the design concept. So I'll go through the two initial slides to cope up or move into it. What happened? So basically, we start. I am working in this area long back. Specifically, I started in WSN and managed 2000, then WSN in subsequently. Now we are working on IoT. But my areas,
which I need to prepare a little bit. Huh? So
Okay.
can I leave the meeting right now? You can manage.
Okay. Okay, fine.
Okay.
Okay. So, okay. So we are working for long time in this area. However, it's task given to me. It's a very tough job. Why? Because of IoT architecture. For me, it is bandwagon, starting from physical layer, data link layer, communication layer, and protocol layers and other layers. I'll try to make some justice to it. So first is, as you have seen here, that everything is evolved around industry requirement, automation specifically, and there is about this there is a talk few days later. I don't want to talk too much. I want to talk only the industry 4.0 physical system, Internet of Things and network. So this is, and if we go to the other side of the story, is that IoT generate huge data, so big data, and big data we have to process, that is AI or machine learning. Based on the learning, we have to put it into the action, that may be robot, that may be anything, and finally back again to start generate sense data by sensor, by intelligent these things, process it and do it, continue this process. And if you look into this is nothing but Society 5.0. So today, there are two coin words, Industry 4.0 and Society 5.0. If anyone is ready to study, can study these two things, you'll find it how very good, important this IoT things. Now coming to cyber physical system, is basically three things we have to keep in mind in our study related to IoT. One is computations. What extra things is not here is the sensing. So computations based on sensing data, then communication and control those things. So smart industry, already previous speaker has talked about it. The smart industry require automation, they require flexibility, they require user interface, they require big data analysis. All these are based on the data collected from the devices, that is sensors or intelligent sensors, that is IoT. So if we look into the industry 4.0, first thing is interoperability. That means connect anything and communicate each other. That is Internet of Service. That basically, obviously the virtualization, so physical things and the virtual things. So all physical things appears in the cloud domain as a virtual, as well as additional virtual things are there, which are controlling or processing data from the physical devices, whatever they get. And obviously it has to be decentralization, and because it is industry, it has to be real time, and it should be service oriented, and it should be modular. So if you look into this industry 4.0, which the next speaker in coming few days will talk about it, I am just putting in one few slides. Why? Because it is our backbone for IoT protocols and other things. So basically, we get data, then do the analytics. Data we get from the sensors or actuators, actuate it, get sensor, analytic, autonomous robot actuate it. We simulate the environment, then we'll do all these things. Finally, this. But Industry 4.0 actually talks about industrial IoT because industrial automations. So the basic thing driving is we have autonomous robot which can be actuated. We require connections and we require security. And system integration, over and above the questions in the last speakers, big data analytics, Internet of Things, data collected, where I will do analytics, what I will do, which place I will do more, those are all these things to be looked into. So smart means intelligence. There are synonyms. For example, NVIDIA is working in different institute and they're just giving a lot of things. So every industry wants intelligence, whatever level it is required. NVIDIA is one of the things, organization engaged in deep learning, and deep learning require data, and data is the all data we collect from connected devices. So automation and artificial intelligence, this is going to be the future, and specifically machine learning. And if you go through the data, you will find that most of the places or most of the automation industries, most of the smart city, most of the places, the AI and automations taking care of everything. Obviously, it is taking care of some jobs. However, it creates also sophisticated or very experienced people jobs. So if I come to the Internet of Things, my Industry 4.0, which encompasses automobile industry and others, then Industrial Internet of Things, that is sensor mechanism, factory area, network, mining, catering, everything together, and over and above the day-to-day life and society all together, we put it into one black box at the bigger umbrella, that is Internet of Things. So this definition, I don't want to go about it. You have already got it. Only thing we have to remember, the physical object, the device, vehicle, building, and other embedded electronics, software, sensor, connectivity to that enable these objects to collect and exchange data, but doesn't talks about processing, which left out here. So promises are already discussed by previous speakers. Smart home, smart city, smart business, smart government, so many healthcare and everywhere, this use of Internet things. So if we go by this, that today 50 billion devices are connected, and day by day they are connected. So today IoT is everywhere, and this is the big picture. Anyone can say, look into it, but it was created for machine-to-machine communications. Please remember, machine-to-machine communications is nothing but Internet thing also in different name. Similarly, Internet of everything, Internet of anything, all are nothing but different groups has different way they have projected. Widely used is machine-to-machine and Internet of Things. And if you look into this picture, it is available in Internet also. The every directions, this Internet of Things proliferates, and everywhere you will find its usage. For example, the healthcare and life science, if you go to the hospital, there are equipments, all equipments are connected, and all equipments are monitoring. And similarly, body area network, they look into the each and everything, and of the body pulses and everything, all, and process it and inform to the doctor, and doctor can give information back to the patients and continue. So this is a big picture. These slides talks about where IoT cannot be used, or everywhere, anywhere, ubiquitous. So IoT technology, if I look into it, that is a hardware device, there is a communication technology, there are protocols, then automatically software, and finally the cloud platform. And a ready-made IoT device are You can look into these ready-made IoT devices are here. There are Arduino, BeagleBone, Galileo, Raspberry Pi, and this thing can be utilized. And anyone can develop in and around some IoT equipments for a particular purpose. And if you look in these various sensors and actuators, it is used in different purposes, being flow, force, load, torque, strain, pressure, everything related to car, leakage, accelerations, and each and every area you will find there are various sensors or actuators available, and these sensors and actuators together with internet can do a lot of things. And if we look into the sensors available, it's a big list, starting from 7-color flash to bicolor mini to different devices available which can be plugged into such Raspberry Pi, BeagleBone, or any other interfaces, and anyone can build one systems and can use it wherever they like, be research or be verification of protocol developed during research or prototype designing or automations or any such things. So if I look into IoT technology, the communications, there are lot of options available. One is the 3GPP, one non-3GPP, and one side of the other side, all standards, other standards. So if you look into the cloud, from point of view, which today's one of the important things is that sensor and sensor owner collect the data and publish to a broker that's called sensor publishers, and the sensor publishers publish this data based on the subscriber subscribe, it provide the data, and consumer subscribe to the sensor data based on the access and authorizations, they get access to the sensor data. So if I look to IoT communications are or should be low cost, low power, long battery durations, high number of connections already discussed, different bit rate requirement, and obviously earlier it was started with short range, obviously it is long range, low processing capacity, low storage capacity, small sizes devices because packaging and placement and will be easy, and over and at last, simple network architecture protocol. So where I have to talk, that is the simple network architecture protocol, because protocol cannot be very heavy for this purpose. And obviously, all are wireless technology, because we are talking about devices which can communicate, do some work and communicate with each other in a manner. So all are based on wireless technology connections. If I look into the diversity of IoT applications, there is a varying bandwidth requirement, depends on application. If it's a smart city, CCTV camera, then automatically bandwidth requirement very high. And if I have to measure a temperature, bandwidth is very small requirement. And there is a group of thoughts, and they're talking, discussing, or fighting, or coming up with these things, short range versus long range, and obviously longer battery life, as earlier speaker has mentioned it. And at last, various QoS requirement. That is basically here it is reliable delivery. That's the basic questions, because our protocols and architectures are very simple, and we cannot have a complex protocol. As we don't have complex protocol, we cannot have QoS requirement stringent. So specifically, the reliable delivery, it is looked into it. So if we look into this, spectrum needs to be made available in range of frequency, bandwidth, bands to cater for various cases. And over and above, IoTs and cloud technologies and are the two unstoppable forces, are the two unstoppable promoting digital capability. So basically, cloud technology and IoT together, making whole world digitally dependent. I put it this as digitally dependent for good purpose. Now, if I come to the IoT reference model, which was given by ITU TY.2060, is basically, if you read in IoT solution supporting FC here stands for fog computing. Part of the, now question is that what is fog computing will come later on in the subsequent slides. So basically talks about, we have a device layer, device capabilities and gateway capabilities, which is talks about the device that is enabling communication and sensing and communications, and the communication technology dictate the gateway capabilities. So basically one set of architecture in the device layer, that is device sensing and communication is Zigbee type of topology architecture. If it is Wi-Fi hello, then it is some other kind of architectures and so on. And it comes to the network layer, addressing, logical addressing, though the device layer is the physical addressing, the network layer is the logical addressing, while IPv6 and some routing protocol layer, RPL, they are playing big role here. And over and above UDP or UDP capable as a transport has to be put it in here. And finally, the upper two layers are the application layer, where we'll discuss the MQTT, then the extreme upper layer where COAP will come in picture. And if you look into the vertical both sides, if you look into the one side is the management, another side is the security capability. For example, if we go for the smart cities, already mentions in the smart architecture for smart sustainable city, if you'll find sensor layers, are a lot of sensor, camera, RFID reader, GPS tracker, all these things are sensors. Then there is a capability, how capillary network, this is called capillary network because this is built in using the sensing to communicate data, physical communications, and that is available in capillary network. Over and above, we will have other network, the long haul network or Wi-Fi network or other network to communicate it. And over that is the data and support layer where we collect informations and process informations, communicate each other application, and finally process those business and come to the application layer. If you do IoT usage, if you look into that, you will find the spectrum use is, if you look into the scenario here, you will find that there are the technology and the protocol available here. We can use the white space spectrum, that is 802.11ah or TV white space. We can have option for communication of satellite. We can have M2M IoT, that is private telemetry and this, then WAN, W1, PAN, LAN, all these things type of network you can get it and use them for the dense urban populations, that is the coverage. So one important thing I forgot to mention that sensors or IoT, there are three things we have to keep in mind. One is sensing, the sensing purpose, what purpose it was deployed, the sensing. So sensing should have a coverage. So that is one of the research topic, and everyone is working since last more than almost 2 decades, the sensing coverage, how there should not be any hole, And this sensing coverage, it talks about the sensors. Then it is a communication coverage. Sensors should communicate each other. That is the communication coverage. So sensing coverage, communication coverage, these two together makes the connectivity as well as this. So, and computation capability also we build in inside the systems with intelligence, then it will become IoT because they can do certain kind of intelligence within them. Obviously, spectrum use, there are issue, and most of us, we are using the unlicensed spectrum. Let us see. So, IoT connectivity options, if we look into it, we have option for license as well as unlicensed options. The licensed spectrum, we have ECGSM, narrowband IoT, that is basically low power local wide area options. License spectrum also LTA, LTM, that is a wideband. PMR, the personal radio, personal mobile radio, telemetry and others automations, satellite, and unlicensed LPWA or LPAA. And generic architectures from the top level view, if we look into it, we have two scenarios. One scenario is long range, another scenario is short range, and we have a technology. Short range usually sensors and actuators, and they use different communication technology. We'll discuss subsequently. We have several other technology which is for long range options. So industry as well as the personal sphere. So if we look into this IoT technical solutions, cellular M2M and non-cellular M2M. By the way, I am using M2M as well as IoT alternately. They are same as far as my discussion is concerned. If you look into this non-cellular, there are a lot of standards, and cellular, there are also few standards. Coming into this, because IoT evolved from different companies, starting from M2M, Internet of Everything, Internet of Things, Internet of Anythings, like this. So several proprietary standards available, and few open standards also available. And if I look into this 4-layer model, first is sensing and identifications. One sensing and identification and low-level communication is done. Then we require network infrastructure to communicate that data to the cloud or wherever users available in a nice, that place should reach the storage. And that storage data has to be processed by information processing, AI, ML, or any such techniques. Maybe we'll have optimization to find the things, data mining, all kind of things we'll use in the information processing. And finally, we'll put them in together as a business logic and system point of view, smart city, smart agriculture, that point of view, integrated applications. So this is a 4-layer scenario. And if we see this IoT reference model, there are two parts. One is operation technology. You can see this side, the right side, operational technology, where data in motion, and information technology, when data at rest. And if you look in left side, you will find, that physical device and control, this is basically the Internet of Things, where these things are happening and communications. And when it comes to connectivity, it's basically the edge, they are connecting to the different network level connections, logical connections, and their processings. And then next level will come edge computing. That what edge computing is very, very important in IoT scenario.
sometimes people say that fog computing, they are very close to each other. I don't want to go between them. For me, both are appears to be same because it is the sensor very close to sensors. The devices having more capability, they collect those data, try to process the data aggregations, compressions, and also some data which no redundancy removal, only those data which can be communicated to the cloud or the data accumulation or storage place, because all data communicating is a costly affairs. So some of the data can be minimized and some action can be taken at the edge computing level or the end system devices level where capability exists. So it comes to the data accumulations. Once data accumulation is available, we can do data abstractions. Obviously, data can be presented in such a way, those data can be processed, and finally, applications, analysis, and other things. At the end, we'll have a collaboration and process orchestration one place. We can do most of the things. So if we look into the requirement, design requirement, the scale, obviously tens of thousands sensors given site and more than that and distributed geographically. And obviously it is heterogeneous because vast array of sensor, actuators, smart device, some of them are IP capable, some of the non-IP capable. We'll discuss this issue. Obviously, the different companies, so it's a very heterogeneous, which is a tough job. Low capex is one of the requirement and OPEX, because it should not have too much operations or too much deployment issue. So all sensor actuator has to be, or the IoT device has to be as less cost as possible so that we can deploy and use it. So capex cost should be, and operation time, the communication cost has to be as minimum as possible, and maintenance cost as minimum. True sense, there is no maintenance. Once the battery will over, and it will be considered as not so defined. And obviously critical services, some cases it can be utilized like human life critical, body area network and others, and critical infrastructure like grid. If grid one failure, the subsequent lot of things can happen. Obviously, intrusiveness is one of the important things we have to look into it. It's a security point of view. And so end user should not get, only the intended end user should get it, rest others should not get it and misuse the information. And geography, there is no geography as far as IoT is concerned. And if we look into the network connectivity requirement, all are resource constant endpoints. At the end, they are very resource constant. Their memory is very less. Their compute power is very less. And their communication capability has to be minimized so that their battery power can be sustained. So low power, that is already I have mentioned, most of the time they sleep. As most of the time the devices, IoT devices sleep, so our protocol or architecture has to be in such a way, adapt to into the sleep schedules, sleep and wake up schedules. That is one of the important research area. So most of the device should sleep as much as possible so that battery can be remain with them for future usage. And it is obviously embedded into the systems. For example, some of the things are put inside the building infrastructure. Similarly, inside the human body also, we are putting some of the IoT devices. So they are embedded. Longevity already I have mentioned. If I have put it into the human body, the life should be till human die, that much time. So longevity is one of the big issue. And high sensitivity on receptions, that is basically gateway or end device with high sensitivity around. This is first speaker has mentioned specifically the interference, not from the physical interference, the communication interference is one of the electrical interference or piezoelectric interference. The interference here is one of the important requirement, because if interference is more, then obviously device will not work. So one of the important area of research is how to minimize interference, so that multiple technology using same channel or same bandwidth or same range of bandwidth can coexist. That is, interference is one of the important area. Now, if I look into the IoT technical solutions, I have fixed short range and we have long range technology. Let us see. RFID is already talked about it. I am not going to talk. RFID is basically one of the technology which is very, very important. Nowadays, everywhere it is in use. That can be active, that can be passive, it can be purely all these things. And so, and this RFID, as Professor Bhattacharya mentioned, is the starting point of our IoT. And RFID is here and going to be here for a long time for communication. RFID is one of the IoT devices. Bluetooth is everyone is using in their mobile phone, and it is have a capability. And obviously, BLE, Bluetooth Low Energy, is very, very popular and nowadays available for personal area network, and we are utilizing. And if you look into this, the range, if you look into this, the maximum power and range, it is 1 meter to 100 meters, short range. If you look to Zigbee, Zigbee is a de facto standard for present IoT, the physical layer communication protocols, that it has a coordinator. If you look into this has a coordinator, and the coordinator communicate to the Zigbee router. This is an architecture as far as Zigbee technology, Zigbee network is called Zigbee technology. This is one architecture. You have end devices, you have router, you have Zigbee coordinator, and outside network can communicate from Zigbee coordinators. So as I mentioned, the architecture is protocol dependent, technology dependent. It has to be read by that point of view. So Zigbee is one, and Zigbee, lot of improvements are coming up, and also people are working, developing standards. Now, if you look into the Wi-Fi already everyone is using. And if you look here, Wi-Fi is usually small size, low cost and low power, and it can be used for various requirements. The home building automation, smart energy, multimedia, security, safety, M2M, industrial M2M communications, in which, if you look, the A, B, G, N, SE, all are the A, B, G, and SE are already available in our devices, laptop, and others. I am interested to talk one, that IEEE 802.11ah, and if you look into this, it can go. It's a long distance. This is called Wi-Fi Hello. Wi-Fi Hello is basically nothing but 802.11ah, which is for long distance communications, a new low power long range version of Wi-Fi that IoT connections. And obviously Wi-Fi Hello related protocol development, architectural issue, and channel, how many channel it is used, what are the things, how they coexist, the architecture is also very, very important. And Hello is based on this, and Wi-Fi Hello works on sub-band, sub-gigaband, and 900 megahertz, and it works in today in 900 megahertz, 2.4 gigahertz, or 5 gigahertz AC channel. And if you look, it's a sub 1 gigahertz channel, flexible bandwidth, and it has Wi-Fi IoT brand, and extended range up to 1.5 kilometer, whereas the indoor Wi-Fi is that A, B, C, N is 100 meters or that. And if you look into this, it can go up to 15 Mbps and low power consumptions. And if you look support up to 8191 devices, 8,191 devices. So the situation is going on the other directions. And if you go to the long range communication solutions, there are two groups, 3GPP and non-3GPP. As I mentioned, this whole IoT developed on their different groups, and different groups came up with different proprietary protocols, proprietary architectures, and the standard group, they have also their architectures. So if you look, LoRa, Sigfox, Weightless, and others are the non-3GPP standard, and whereas LTE, long time evolution, machine type communications, ECGSM, narrowband IoT, and 5G, the other standards. Most of the, some of them next set of speakers will talk about it. I am only put some features here. That is, LoRa is low power wide area network, and it is huge cheap spectrum. It is high sensitivity and nodes and gateway up to this. It can go up to 15 kilometers. That's why people today, most of the people are going for rural IoT applications. They're using LoRa, and you can look into it. A lot of research work is going on how LoRa can be utilized, and LoRa MAC layer protocols, LoRa B MAC layer, then what should be the network layer protocols? If LoRa is there, what kind of small QoS issues can be built in? All these are big research topic, and several groups are working in the application of LoRa in IoT environment. And LoRa has a basic important things, resistance to Doppler effect for multipath and signal awakening. And if you look into the LoRa architectures, you will find it end-to-end device. It can be go across the cloud to another site by the LoRa gateway, or it can do only the end device is very close to each other, and it depends on how data collected. If you look, there is LoRa gateway, and it is coming to the server. Server is application server, and is a cloud. The application server, any email, customer ID, remote monitoring, everything can be done from the application server, and it uses AES encryption from security point of view. And throughput is not that high, that you have to remember. So LoRa has three options, A, B, C, that is plus, and it depends on the communication and their working. Please read from the slide. I don't want to spend here because we have to go to the other slides. Similarly, Sigfox is another private standard, and they have come up with similar to LoRa, but they are proprietary standard, and they have already deployed 60 countries related to IoT applications. If you look into this, it was the first low power wide area network technology using BPSK. Physical layer is based on ultra narrowband wireless communication. However, it is a proprietary system. Throughput is very low power, but it can go up to 50 kilometers. And it is basically, if you look here, the data is subscription-based model. That is, you subscribe, you will get the data. It's one kind of push model, not pull model. We'll discuss push and pull model subsequently. And it has a roaming capability. And if you look into the architecture, similar kind of the architecture connectivity, but instead of the, already we have discussed earlier that LoRa, similar to LoRa, but it's equivalent and similar architecture they follow. But this Sigfox, the initial one, there was no security built in, and So that's one question to be looked into it, but it's as a proprietary standard, how much we can penetrate, we don't know. Now, another class is a very important class, is called weightless. Weightless came from a company and they developed this, and weightless is basically optimized. Weightless is a wireless technology for M2M. If you look, that can go up to 10 Mbps, but here it is 13 kilometer is written. Actually, 5 kilometer is what is called recommended. And the payload, if you go 200 bytes, and security will be AES. And weightless is first version released on this, and today already deployed in 2017, it is deployed in London, and there are three options: weightless N, weightless P, and weightless other part. This, if you see, weightless N was first designed. It was for one-way communications, and it is designed in such a way battery life can be 10 years. This is very, very important. You have to notice that once it's designed, the device can work for 10 years, which is very, and terminal cost is very low, network cost is very, communication, and data rate can go to 10 Mbps. So if you look into this, the battery life is play a big role, and the technology is providing that. This is another private technology which talks about random phase multiple access technology, and it is basically wide area channel access mechanism, and again it is designed for M2M. And RPMA is a direct sequence spread spectrum using convolution channel coding, what we have studied in wireless network communications, and gold codes for spreading, and 1 megahertz bandwidth, and it uses two TDM frame, that is one for downlink, another for uplink, and the standard is defined. It's a closed loop power control, so that power can be power wastage can be minimized. And if you look into the other architectures, that's LTE to LTE-M. LTE, if you look into LTE-M, there are LTE-M is machine type. What we are using LTE-A. And if you look into the LTE-A, you have a EU term where E node B are connected, E node B's are connected to user equipment. And user equipment, whatever data is given, it is coming to service gateway and the PDN, packet data switch network gateway, and finally going to the outside. What is this NTM is looking into? They have changed the baseband software here, E node B, so that it can work on narrowband, and access technology, they changed it, and range can up to 11 kilometer, throughput can be 1 Mbps. So they not change many things. They have already, they are already existing LTE, they adapt, change the baseband software. If you go to NB-IoT, it's a similar like this, and it is also ultra low band, and the structure remain almost same. Only the software and technology is changed here. So what I wanted to convey is that the whole process, that underlying technology help data to be collected from the devices and available to the respective places like E node B or gateway or somewhere. On top of it, we can run IP network. That's the basic things. So based on this idea, this lower architectures and connectivity, we can come up with the next level architectures at the level of network layer. One of them is 6LoWPAN, low power wireless personal area network. This, why it is required, we'll talk. Then MQTT, message queuing telemetry transport. Then like this, there are other protocols. These protocols I will discuss in details in next lecture on, I think, first. I'll discuss in details. Today, I will talk only a gist, each and every cases. First of all, so many devices, the billions and billions of IoT devices should have one address and should be accessible from anywhere in the world. That is a logical address. And the logical address and the physical address given by the low layer technology, the mapping I am not talking. I am mainly talking the logical addressing. And logical addressing, we have option at this moment, widely used it IPv6. And IPv6, if I go into the IPv6 and look into the IPv6, the header is 40 bytes and every address is 128 bits. Every machine address is 128 bits, and everyone, or it was accepted that if 128 bit addressing whole world, the addressing scheme will take care of each and every element in the world in future also. So it is very, very acceptable options. However, if I look into this, header is 40 bytes and we have minimum packet, IPv6 packet size is 1280 bytes, 1280 bytes. But the underlying technology, the physical connection topology, whatever till now I discussed, for example, 6LoWPAN, that is 6LoWPAN is mainly designed for ZigBee. And if we go to ZigBee, the data link layer packet size, so, or what is called the data link layer, the datagram size is 127 bytes. And if we go in details, out of 127 bytes, only 81 bytes are available for payload. Why? The ZigBee has an addressing scheme because it's a data link layer. We have a data link layer header, and the header will take care of several bytes. So 81 bytes are available for payload, whereas IPv6 having minimum packet size is 1280 bytes. So how it can go? And that's why there is a separate sublayer created below IPv6 layer that is called 6LoWPAN layer. And the 6LoWPAN layer duty is IPv6 packet can be efficiently transferred to the radio link. And to do that, we have to do 1280 packets bytes minimum, and it can be any size to be fragmented and reassembly, which is against the rule of IPv6. Because IPv6, there is no fragmentation option. But for our IoT, we have no other choice because most of the technology, lower layer technology, the number of bytes it can send per datagram is around 200. So bytes maximum. So automatically fragmentation and reassembly is coming. And obviously we have to do the header compression to minimize the communication cost. And it has to also look into that layer 2 forwarding. If you don't know, please read. There is a term called layer 2 forwarding. We'll discuss in details in next lecture. The multi-hop scenario, the layer 2 forwarding also can help minimize the cost. So basically, IP6LoWPAN is actually, if we look into this, where will be 6LoWPAN? The sensor area which is marked in this circle is basically 6LoWPAN network. And this network connected to one edge router. This is called 6BR router, 6BR, IPv6 border router. One side can be IPv6 or dual stack IPv4 or IPv6. The other side is IPv6 low PAN, so that the communication from every device can be reached to the router, and the edge router combine them into IPv6 packet and communicate it to the other side. There is one question may arise, some of you, there are some controller, you will study the controller in subsequent classes, lectures. The controller, some of the controller are addressable, and controller are connected to lot of sensors or devices. How I will address those devices? Because I don't have option to connect those controller directly, but I have to go through the controller, and controller is accessible by IPv6. So obviously, to access those devices, we have to approach to the controller, and another port number I have to use, or the socket number we have to use to access those devices. So what I am talking, there are two issues. One is addressing to identify each and every devices logically, and another things I am talking related to the communications, because IPv6 also used for routing purpose, so communication has to be continued. But in case of controller, those devices connected to the controller, they are only sensing and reporting to the controller. The devices do not have any option to communicate. So controller is actually communicating. Hope this helped you. Next, what I am talking next is the basic important one. If you look into this, if this picture is visible, if you can look into it, standard network, whatever we know, all are byte stream, because we have a TCP and all data is going to TCP making into byte stream, it is giving to IP, then IP is giving to the lower layer, data link layer, and data link layer to physical layer, and going back, and finally we are getting back again bit stream and combining them, and we are getting here. Okay. Oh, but before that, let me say something about it. Here I forgot one important things. This 6 low PAN, I forgot one thing I want to repeat here. 6 low PAN, how it works and details I will discuss in subsequent class. But remember, 6 low PAN introduced fragmentation and reassembly, which is against the principle of IP version 6, because IP version 6 wanted to reduce the fragmentation related attack, the fragmentation death attacks, or those denial of service, or all those things, those security attacks, they avoid. That's why they want to intend to avoid. That's why IP version 6, there was no fragmentation and reassembly. However, as we added this 6 low PAN, automatically we added the attack related to fragmentation attack in wire network. So all attacks which are possible in wire scenario are applicable to this IoT network related to fragmentation and reassembly attack. So you can do little more inside of this when the security related discussion will be continue. I think the person will take care of it. Back to this. So today's our network, whichever you are using present day, all are byte stream. But byte stream require lot of complex algorithms. Specifically, if I have to make it reliable delivery, so it has to be connection oriented, order delivery, and so forth. So automatically cost of complexity will increase. as I mentioned, one of the important thing, simple protocols and architectures are required. Considering that, if you go into the Twitters, WhatsApp, Instagram, Snapchat, Facebook, if you look into there, they came up with different mechanisms. They have push mechanism, they have pull mechanism. So it depends on how it is implemented. So for example, you have heard about REST. If you have not heard about REST, we may discuss, you can flag on it, I may discuss it next time. Representational state transfer, REST. It's basically derived from HTTP. HTTP, this is here, this one is shown here. HTTP is connectionless protocol. HTTP has get, put, post, delete. These are the only four. Get, put, post, delete. These are the only four HTTP options are incorporated in REST. And this REST, whenever it sends one request, it defines request in such a way, from the request, the application can understand state of the requirement. And state of the requirement is, based on that, it will run in a server and get its response and back to the browser what is the requirement. So basically, it's a request response paradigm, and which is implemented in COAP, Constant Application Protocol, which is one of the important area which application layer is using. Is basically running over UDP, and it's not HTTP, it is a variant of REST implemented in IoT environment. Now, if we go to the other part of the things, it's called producer-consumer paradigm, where you can have a broker. So broker in between the subscriber and publishers. Publisher publish their information to the broker, subscriber subscribe to the broker and get those informations. And this is producer-consumer paradigm, publish and subscribe. So here there are several issues exist in which MQTT, that is message queuing telemetry transport, which is used in IoT, advanced message queuing protocol, and XMPP is similar, also called Jabber, is designed based on this. Your assumption is that there should be a broker and everyone to subscribe. For example, broker has to be subscribed. Everyone has to subscribe, and it's a push mechanism. It's a push mechanism. And whereas this REST and COAP is the pull mechanism. What is pull mechanism? As and when I require, I will send my request with sufficient information, which request contain my state, and the server will read all these things, compute it, and send me back the result. So it's a pulling. I am asking data and getting. Push mechanism is I am given the subscribe it, as and when data available, please provide me. Or if you have data, immediately you put it. So I subscribe model. So it's a publisher subscriber model. You can say it is basically NDN type, name data network type, where data anyone can subscribe and get the data if it is available. So basic things, I think I reached 1:30, so I have to stop somewhere. Basic philosophy behind each publication subscription frame model, and here again use only few messaging protocols, that publish, subscribe, publish act, publish release, publish receipt. So you have message one is publish, Then message 2 will be published at. Message 3 can be published. Message type can be published received. Message 4, another type is called publish release. Then these are the 4 different publish related message. Similarly, subscribe, another message. Subscribe act is another message. And there is also unsubscribe, subscribe act. So only few set of messages is used to communicate each other and get. Obviously, our assumption is that there is authorization inbuilt it, authentication, authorization, and access control are already built in, and that is there. And if it is there, then these messages can continue. Otherwise, if there is access is not there, it will not be allowed. So I am coming to the real end. Today, I will not talk more than this. I will talk at the last slide here. We are data-driven society, and we visualize data in a meaningful manner. Various things and people where IoTs are here, that is the physical space, all informations we gathered by architecture, connectivity, protocol, that is sensing, digitization, conversion, extents of data, and communicated all data to the IT. So OT, operation technology, data on move, we move data to real world transmissions and accumulated in the storage. And once storage is available, we have big data. And if big data is available, what we can do? We can analyze it. And what analysis we can do? Machine learning technique can be used, or any other technique can be used, and try to find usefulness, and ultimately will use for a certain purpose. And finally, we'll back into the utilization service. Based on the data, we put it in the utilization service. It may be health, it may be smart factory, it may be anything. And finally, once we have implemented the whole things, then automatically feedback to the real world is necessary. So it is a feedback. And once this, automatically we can look into the social issue. Based on this, we require everyone in the society, be computer science, be electronics, be electrical, be mechanical, civil, economics, mathematicians, statistics, all, and also humanities and social science, where behavior study, all things together is a circle. So we are in this circle. We are only talking about the IoT part. And before any question can arise, I am talking about today some of the IoT device, a miniature form, machine learning, reinforcement learning, DNN, deep neural network, CNN, RNN, all kind of things, a miniaturized form already available in the IoT devices for a particular purpose, not general purpose. So let me end it. We are here, we are talking about IoT, that IoT is giving data. We are not at all talking about data processing, and we are not talking about anything. We are only talking about what is IoT, how we are collecting those data, and how we are bringing into a place where or process in particular level so that we can get a meaningful data, and that meaningful data we can utilize for some purpose. So I tried to give some overview of the architectures in the lower level and the upper level at the network level, and more I will give you the next class. Thank you. If you have questions, please let me know.
Thank you, sir. So there are a few couple of questions. Can I read it out, sir?
Okay, let me stop. I can read also.
Yeah.
Which one is the first?
Sir, in the three dot at the bottom of the screen, if you click, there is a question answer section, sir. You can just click the.
I am looking.
Sir, there is a question from Mr. Adesh Kumar.
Adesh Kumar, yes.
Yeah.
How many bits encryption decryption is applicable with the architecture as multiple nodes are there? Is there any effective electromagnetic interference? See, Adesh ji, what I got from these questions is basically there are two parts. One part related to the encryption decryption, other part related to the electromagnetic interference. First part, bit encryption or decryption of capabilities, obviously it is all these cases, most of the cases, they use stream cipher and stream cipher based encryption decryptions. And stream cipher can be AES based or Chachapoli or a variant. And because it has to be very small time, it has to be encrypt and decrypt. So time consumption and computations is one of the issue, and it should not be highly resource consumed. So stream cipher is used, and 1 minute, though I am moving. Okay. So stream cipher is used. Then authentication purpose, it is authentication assumed to be there. So integrity checking, there is use called CBC type cipher, a variant of CBC, cipher blockchaining. It is used there because again resource constraint is one of the big issue. Coming to the electromagnetic interference, yes, what you have, some of your asked the Professor Bhattacharya also, that packaging. So basic philosophy is that how to reduce the interference. There are two ways possible. One is the modulation as well as the range, communication range, modulations, and other MIMO and all these things, but too many complex things cannot be possible. So automatically interference has to be minimized. That's why short range communication is preferable compared to the long range communications. Next question from same persons, I forgot where it is. Please clarify machine to machine communication is done in 4G, 5G, LDPC and popular code. Yes, this part, I think there is a lecture on 5G and others. You can get there. Direct sequence inspection convolution cut is very old, but please remember, it is not that old because turbo coding is your mobile is implemented already, turbo coding and others. So convolution code is not old. A variant of convolution code is there to minimize the error, okay, compensate to minimize the error. So I think this part will be discussed by subsequent speaker. And this is Adesh. Then can someone please upload? Then what is this? How do physical layer technology limit the implementation of it? Can give example. Okay. So if you Zigbee, for example, Zigbee, if you read the Zigbee, you will find there are options. How many devices can be together in a Zigbee network? And if you assume the small Zigbee network and connected to each other by other network or extended network can take care of this. So basically physical layer technology is not the correct, that technology at the data link layer or those technology, physical layer technology is basically they have a limitations. How many devices can be connected? What are the topology they will be connected is a dependent. However, if you have distributed systems, that is one chunk or one network connected to the other network easily can be combined and we can increase the communications. So range of communications can be or connectivity can be increased. What are the difference between publisher subscription model? Is basically producer consumer. It is a producer consumer, same thing is publisher subscriber. A person wants to give some data, or what broker means dalal. You can say that those are in between, intermediate. Intermediator get things from publishers, keep it their store, and whoever want to subscribe to that and get it. That's the basically producer consumer, same formula. It is the publishers and subscriber. Publisher publish the data and subscriber accept the data. That's a publisher subscriber model. What is the IoT impact in agriculture? Way of aspect, research aspect. Yeah, this is a huge research topic. Rajuji, this is very research topic in agriculture scenario, and hope if we get chance sometime we can talk it, because agriculture depends on the what kind of agriculture you are talking. If it is a paddy, one kind. If it is a what is called cotton, it is another kind. If it is a tea, it's another kind. If you talk about tea, the moisture content, the soil testing, then water level, then the what is called soil different pH level and other things you have to see, and accordingly the water supply and other things. So it's a big things for us and big research topic. Cloud computing platform, open source is a very easy thing. So you can get it from anywhere in the net. It's easy, and if you find difficulty, you can send message. We will provide links. License or license, which is better for IoT share? It is basically totally depends on application point of view. Whoever is using, it's a full service provider or application point of view. It nothing to do with which one. Obviously, we academician, we whoever doing researcher, we are using unlicensed spectrum because easy to do research, easy to implement, easy to test it. But whereas licensed spectrum is basically money is there and it has to be specific purpose. Obviously, licensed spectrum is more secure, more authentications are possible. Can asymmetric encryption be used? No, sir. Asymmetric encryption usage is rare because it's too costly. Too costly. It can be used mainly the key exchange point of view. Sir, please discuss basic of 5G cellular internet. This part will be Shashank Tripathi ji. It will be discussed by Professor Bhattacharya subsequent lecture. I am not talking at this moment. Sir, which technology best for networking 10-kilometer range? Please go through my slide. You can get it. Obviously, it will be the what is called. I am forgetting. License band. It will be license band. I'm forgetting. I have in a slide. This is basically towards the cellular. That is LTM, EC, GCM. Then you have the last. I also talk about Wi-Fi Hello. Wi-Fi Hello can be utilized. How much performance decreases? We use short range area to long range area as this. The Zigbee is specifically designed for short range communication, and it works on 2.4 gigahertz. Similarly, Wi-Fi also works for 4 gigahertz or 2.4 gigahertz. If you are student of electronics or person from electronics, communication engineering, there is how to reduce the interference, specifically spread spectrum techniques, direct sequence spread spectrum, code division spread spectrum, and other things that related minimization interference is a necessity. And obviously, this is one of the big important area, how to reduce interference so that our communication goes. So please read interference minimization techniques, including direct sequence spread spectrum and several spread spectrum technique and what is called MIMO then all these related were relay and other things. Is crowdsourcing part of IoT? Yes, but in what level? That's the question. At what level? That's the question. Crowdsourcing for what? Unless we define it, we cannot say crowdsourcing can be used. Crowdsourcing is part and parcel of our all research, and crowdsourcing is a necessity. But I cannot comment on it because it is very tough to say without a proper logic, proper area or domain or things. Sir, any research option is there in LoRa? Can you please suggest? I have mentioned when I flashed the LoRa slide, nicely I have mentioned it's a huge research topic. At present, my colleague, if you visit my colleague's website, which Manas Khatua, IIT Guwahati, he has published some papers. If you go to Sudhir Mishra, IIT Kharagpur websites, you will find some LoRa related papers are there. LoRa is a question. You can visit IEEE, what is called, tutorial that issues. You will find LoRa related, as well as you go to Elsevier and search for LoRa related research papers. You will find this is hot topic at present. What are the basic IP-based routing protocol in IoT? Only one, 6LoWPAN, nothing else. 6LoWPAN we'll discuss, which is IPv6 routing and RPL, routing protocol layer. There are two routing protocols. One is IPv6 point of view, another is routing protocol layer point of view. Next time I will discuss. Hope I have ended with a number of questions. If anyone having questions, please contact. Please remember our group is working in this area, not in the physical layer, specifically working in the network layer, transport layer, and application layer. Thank you. Okay, so.
Yeah, thank you, sir, for such a wonderful talk, sir. We all enjoyed a lot. And we are having Nandi, sir. It is very fortunate for us because sir worked in this area and many of his research paper has won the best research paper award also. So we are very fortunate to have sir with you with us. And sir, sorry for the few technical issues that we faced.
It's okay.
Thank you, sir.
One thing is there. If anyone is really interested to work, please contact.
Okay, sure, sir. We will provide the contact, sir.
Okay.
Thank you, sir. And sir, Ratnajit sir, asked me to say a word of thanks from his behalf because sir is busy with some other meetings, so sir told me the same. Thank you, sir, for joining us. So with this, we would like to conclude the day one session. Tomorrow from 10 a.m. we will be having our session. We request you all to please be connected with us by 10 a.m. We will start sharp the session by 10 a.m. With this, we conclude the session. Thank you all for joining us.
Thank you, sir. Thank you, Firoza.
Thank you, ma'am.